This tutorial is about how to build an event-sourced application. And this is a different architectural style from the monolithic CRUD application you may be familiar with. We'll be exploring concepts like event sourcing, service-oriented architecture, distributed systems, etc. And you'll see me develop an entire application from beginning to end in this architectural style. Now, I am using a fairly simplistic example. User registration isn't all that complicated, but it is something most applications will have. And this application will be something I can build upon for future tutorials, adding features as I go. It's also something you can use as a bare bones example for your own project, or you can follow along. With that said, a small disclaimer. This video is a tool for learning. Do not put code you found on the internet into your production systems. You need to evaluate each line of code before you do that and really understand it and make sure that it works for your own use case. That said, the code I work on here will be available on GitHub, so be sure to check that out. Now, a couple of months ago, I wrote a sequence of 4 essays on my website about event sourcing. And like I said in those essays, I'm not really going to tell you why you should choose one architectural pattern over another. You really have to evaluate your own use case, your own requirements. But I was more interested in showing how to build event source components, mostly because I felt that there aren't a lot of resources on the topic, without having to pay huge sums of money. And even then, I don't think those resources go into great detail on how to build these sorts of systems. And that's why I wrote those essays. But reading about how to do something is not quite as effective as watching someone do it, which is what this tutorial is all about. It's an actual deep dive in how to build these systems from start to finish. Still, I think I should talk about why I build event source components. Mostly it came as a reaction against all the projects I was working on at the time. Every project I worked on was a big ball of mud, no matter what the programming language was. And I started learning more about event sourcing, service-oriented architecture, and that's when I had a light bulb moment. Now, I'm not saying every application should use this architectural pattern, but what I found was that the concepts I learned there were easily applicable in a different context, even a CRUD application. Now, let's talk about the tech stack. As you can see here, it's pretty simple. We're going to be building a single page application in JavaScript in Vue. Why Vue instead of React? I just like it, that's all. And then we'll be using Ruby. For the web framework, we'll be using Rack. Why Rack instead of Rails? Rails, it's a fine web framework, and it's good at what it does, but it's not the only way to build applications. And if you think about it, all the web frameworks in the Ruby ecosystem use Rack under the hood. Rails, Rota, Sinatra, Hanami. So I think it's important to at least be familiar with it. And of course, for our event source components, we'll be using Eventide project, which is a toolkit to build event source components. And then for our database, we'll be using PostgreSQL. What we will not be using is any type of ORM. So we're not going to be using Active Record or SQL. Now, there's no reason you can't use Rails or Active Record in this architectural style. But the point of this tutorial is really to explore different ways of doing things. Likewise, we won't be using a message bus. I know that in event sourcing, a lot of times people use message buses like Redis or RabbitMQ, but that's not really what we'll be doing. All right, let's get started. Let's open up my editor. Okay, now there are a number of ways I could demonstrate these concepts. When I wrote the essays, I built the component first because that's what I felt people were interested in seeing right away. But without any context for what's happening, how it all fits together, it can be a little confusing. So instead, I'm going to take a different tack. I'll start with the front end and work my way to the back end. And that's what I'm going to do. All right. So I've got my folder here, and I'm going to make a project for my single page application. We'll call it web, and then we'll cd into it, and we'll initialize the Git repository. All right, and now let's see. I think what I'll do next is initialize a project skeleton. Okay, so we have a project skeleton set up. Now this may not look familiar as a JavaScript project. Well, let's just take a look. Okay, so we have our package.json file. We haven't defined any dependencies or dev dependencies yet. We also have this script called install packages. Now, usually you would just do yarn install, but what I found is that what I like to do is have scripts, shell scripts in a project in order to do these kinds of functionality, to do these kinds of functions. Mostly because you have a similar like interface or API when you're working on your web application as you are when you're working on an event source component, and you'll see that later on. We have a dev server where we run our server, and we're actually using Parcel. But we don't have any dependencies defined yet, so let's go ahead and do that. Let's see. Like you saw before, we're using Parcel. We want to add that. We also want to add, no, let's just do that. Okay. We also want to add Vue, and I also like to use Vue router DOM. Okay, let me add a Babel config file. I'm not going to really define any presets. But we will define a plugin. All right. Let us try to run it. Building. Ooh, cannot find Babel plugin JSX. All right, that's okay. We just probably need to add that. Yeah. Okay. All right, let's run this. And let's switch to our browser. Open this up. And yes, that was what I was expecting. All right. Now, what we want to do is print something on the screen. So we'll just open this up. And well, first we need to set up Vue. So we will import create app from Vue. We'll also import the router from Vue router DOM. And then we will create app. And then we will mount it. Okay. Now, actually, we need to pass in the controller here. So what we'll do is we'll create an app. And what we will do is we will export default. We will render, define a render function. Whoops. And then we will return hello world. All right. And set that. And that. All right. And then what we'll do is we'll import that app. And then use that here. Okay, I think I made a mistake here. Maybe I need a div tag. Let me open up my browser. You may not be able to see that, so let me zoom in. Okay, here we go. So we've got a hello world application. Let us move on. Let's test the router, Vue router DOM. You may be wondering if I'm not using React, but I'm using Vue, and I'm using the same React router DOM in syntax, what's the point? And I say, quiet. So I'm going to add a route index folder. Here I'm going to import browser router, and I'm going to import routes. And I'm going to import route from Vue router DOM. Let's see, then render function, return. Let's see. So we want a router. We also want the route path. And let's call this component home. Okay. And then we'll need a home. So we'll just actually, what I will do is take this, copy, and then just paste it here. And then here I will import home from home. There. And then we need to render our router here. So import router view from route, and then delete this, delete that. Let's see. Let's see. Now let's check the build. Everything looks okay. Let's check the browser. Oh, well, that's not what I was expecting. Is there an error here? Let's see if I can figure this out. Oh, I see. I see my mistake. I need to set routes here. And let's check the browser. Yeah, we're back to hello world. Just to make sure that I have this, let's change this. Yes, awesome. Okay. And then let me go back to my editor. Something else we can do is we only have one router defined here. We can also, if we want, define catch-all. So like if they try to go to an address that isn't defined, we will show something that is not found. And let's add that. And we'll just copy this. All right. Okay. All right, let's go back to my browser. And let's just try to go somewhere that is not defined. And here we go. See? Not defined, not found. Cool. What next? What next? What next? Let's close all this. Okay, let us go and actually start going about doing user registration. Okay. Let's put this here. Let's capture an email address. And then let's put an input type text. We'll call it name email, ID email, and then we'll put a placeholder. And then we'll put a submit button. So that will be type submit. And then we'll call it register. All right, let's check the browser. And here, you can see it. I haven't really done any styling. I don't really plan to do much styling in this tutorial, maybe in another one, but for now it functions. But it doesn't really do anything. Let's inspect. We'll pull up the console. Yeah, doesn't really do anything. So let's change that. So let's add some functionality to this. Let's add a form. Tab that over. Actually, what we're gonna need to do is change this to setup and return a lambda function. Okay, so that didn't break anything, I don't think. And now I'm going to define a function, probably going to be async. And then just put a console log here. And then use this form. Do that. And then let's test it. Let's go to the browser and click. What we need to do is prevent the normal submit function from taking place. Let's go back to my editor and go here and prevent default. Okay, back to the browser and click. Yeah, there we go. Let's go back to my editor. Now, what we want to do is collect this email address here from this input and do something with it when we click the button. So what I like to do is define a, well, what we'll use is Vue's composition API. And what that means is we will import ref from Vue, and then we will define email address input, and then so this is a reference, the default value of empty string, and what we'll do is console log the email address input value whenever they click the submit button. Now we need to bind this input to the actual input here, and to do that we use vmodel email address input dot value. All right, let's test that out. Let me go to my browser, come here, test, let's see, John at example.com, register, and yes, here we go, and it works. Let's maybe change that to Jane at example.com. Yep, okay. Let's go back to my editor. Okay, so now we've got data collection working in the browser, but we want to submit it to someplace. What we're going to do is we're going to submit it to a registration API, a Ruby API using Rack. And what I plan to do is use the following message contract. Whatever. This will be a UUID. Registration ID will be a UUID. And email address will be sent as well. You may be wondering, why are we sending a registration ID when we've only got the single input here? And that has to do with a little thing called idempotency. In distributed systems, you really have to plan for the worst case. And if you've ever seen an application in the wild and there's like a don't click twice message next to the button, or there's some sort of script that runs and makes this unclickable, then you've seen a system that isn't idempotent. So like this, multiple clicks, and they actuate the same functionality. And why is that a problem? Well, if this button right here has some kind of side effect like charging a credit card, you don't really want to do that twice. That's really an operation you only want to do once. So to mitigate that, you send with each operation a key, and here that key is our registration ID, and that key will be used to check. The system will check, hey, did I already get a request with this key? And if you did, then you know, don't process this message again. And for that, we're going to need to add UUID. Okay. And then here we can import v4 as UUID v4 from UUID. Let's do let registration ID equals UUID v4. And then when they click submit, we'll log it. Let's check that out. Let's go to the browser. Okay. Oops, I actually forgot to run my server. Let me just do it off screen here. All right, let's do this. Okay. And yeah, you can see the UUID here. All right, let's go back to my editor. All right. Now, so we're collecting both registration ID and email address. So what we want to do next is we want to submit it to our as of yet non-existent Ruby API. All right, so let's recap. We have a function here called handle submit that is collecting registration ID and email address. But it's not really doing anything with it. It's just logging it to the console. See here, if we just refresh. And then click register, it's logging to the console. Okay. So all we're doing is really logging to console. We want to be able to communicate with a Ruby web API. And maybe it's a good idea to go over how exactly I want that contract to work out. So we have this message contract. This is what's being sent in the body of a post to say localhost right here. In a non-event source application, like a CRUD application, this will be the only thing that you do, and you would be returned back a response with your I don't know. Let's just say uh, something like that. But the problem is that this this operation is happens asynchronously on the server. So it doesn't when in an event source application it happens asynchronously on the server, and so we don't have that information yet. What we need to return back is a way to retrieve that information. Usually how this is done is you return a header, a location header with the with the like with the ID with the location of the resource that you would then query until it's ready. Now, what happens is that it could take like a couple of milliseconds. It could take a couple seconds, and a couple seconds is a long time in when communicating with web APIs. So there's bound to be some HTTP 404 responses. So in that case, what the single page application does is continue to query this address until it responds with the response you're looking for, which would be like HTTP 200 or something like that. And then oops, true. Also, if this email address is unique, we might get like email is email rejected or something like that, or true, as the case may be. And then the single page application can display certain information or errors to the user, as the case may be. So let's recap that again. So what happens is we use this message. We send this message to this resource, and we are returned back a header location with an address of the resource that we want to query. And so we query that with the understanding that we may get some 404 responses because it's all happening asynchronously in the background. So the resource isn't ready yet, and it's missing until finally we do get a proper 200 response with a body that we can parse. With that said, we can go ahead and try to code the web app with that in mind. Now, what I like to do is, it's getting a little bit big. I like to separate out the functionality I want into smaller, concrete pieces. What I'm going to do in this handler file is, I'm going to export a submit registration, and it's going to be async. And it's going to take registration ID and email address. Okay, so we've got that. And we're going to return back a location. So what we're going to do is we're going to form the body here. Okay. Okay, and then email address. Okay. And then we're going to use the fetch API to get a response. For now, we'll just hard code this. We'll just do this right now, and I'll show you why. And then the method will be post. Then the headers. Do we need headers? Yes, because we're using JSON. A content type of application JSON. And then the body, just a JSON stringified of the body. And then if there's an error, then we'll just I don't know. We'll just show the error. Throw new error with the message. Okay. And then now we're going to get the location from the headers. And then we return it. Okay. So that's the submit registration function. We're also going to export another function for querying the registration. And that is this portion. So we've got the header, the location header, and now we're going to query the resource that was returned back. So we got the location. Okay. And now we're going to fetch response. This one will be a get method. I think that's it. I think that's all I need right now. And so we're going to check if the response was a 404. Just remember, we're checking if it's a 404, then the resource isn't ready yet. So the event source component hasn't processed whatever message you sent through the submit registration when you submitted the registration. So we need to let them know what's going on. So we need to throw an error. Now let's throw a not found error. And let's define that all the way up here as a class that we export. All right. And that's about it. So if it's 404, then we throw a new error. And I'll show you what we'll do with that error later on. Next, if there was actually just a problem, then we'll go ahead and throw a new error. The same error. We'll just do the same thing here. Just spit out a response that we can read in the console. And then we will read the data. And then return back whatever the form of the data we were expecting is. Let's just use is registered and is email rejected. Okay, so we've got that. Now we want to use it in here. So we need to import it. We'll import everything that we defined there. Submit registration, not found error, and query registration from handler. Then we'll go ahead and here, we'll leave this here. And then we will try. And then we'll, let's define that location here. And then we'll define this here. And then I think you need to do location. So we'll destructure location from the response. Registration. registration ID. We're passing in registration ID and email address input.value. Let's catch the error. And error dot oops, let me this may not be right, so I'll just do error and then we'll get to that when we get to it. So once we have gotten the location, what we need to do is poll the query. We need to poll this location until we receive back a response. So we need some sort of retry logic here. But before we do that, what we should do is registration location. Okay. Now, actually, I want to destructure this too because I think we're returning. But yes, we're returning back is registered and is. Let's see. Actually, I'll just destructure it is email rejected because the way I'm thinking is if it's not rejected, then it's obviously and if you've received a response and it's not rejected, then it's obviously registered. So let's just do is email rejected. Okay, so we've got that. And then come down here. Let's return after we catch the error. And then if is email rejected, we will return also, but we'll just console. Email was rejected. Probably email address is already in use. Something like that. But if it's not, then we probably want to well, we'll just do some console logs right now. Email address registration successful, and we'll actually do some form stuff later, but right now I'm just trying to demonstrate this. So I think so. What we can't really test this because I don't have the resource available yet. But what I wanted to say is that what we're doing here isn't really polling. There's no retry logic. So what I'm going to do is add some retry logic. Okay. And let's see. Let's do a composable lambda. All right. So what we want to do is we want to pass this function in and then use that to pull the resource. So so let's do this. And we also want to so remember when we were here, we threw a not found error when the resource returned a 404 response code. So we want to be able to, based on certain error types, we want to ignore those. And we want to query for an array of intervals, and then we'll just, this is the query operation that would pass in as well. And then we want to return that. Okay. So we'll have a function or lambda here that checks to see if the type that was we're basically programming a function that checks to see whether any thrown error is of the type that we specified here. All right, error instance of type. Error instance of type, yeah, okay. And then for the intervals, we will create an iterator. And then we're going to create an async function that will basically all it is doing is trying the operation that we've passed in, catching any errors that were thrown, and if it's not one of the retry types that we specify, then we throw that error because something unexpected happened. Okay, so we've defined that function. So we'll have a loop here, and we'll do this operation. Oops. Operation. And if we got something, then we return. Otherwise, an error was probably thrown. An error that we were looking for was probably thrown. So we get one of the intervals, and we did. So the reason we're doing an array of intervals and rather not just like a flat like 10, 100 milliseconds is that we don't want to query indefinitely. All right, that's just bad. We want to set an end limit before to show before we finally give up. So if we've run out of intervals, then we just throw an error. No more retries. Otherwise, let's sleep with the iterated interval value. And I guess I'll define my own sleep function all the way up here. Return a promise. And then set timeout, I think, is the correct one. And then resolve the interview. Okay. Okay. I think that's right. Okay. Now, let's go ahead and import that retry function. And then, so we've submitted the registration. We've got a location. We need to define the operation we want to pass in. It's going to be an async operation, of course. And then it's query registration location. Okay. And then we'll replace this with our operation, retry. Await retry. So not found error. Well, we'll define some retry intervals later, and then our operation. Let's define some retry intervals here. So I like to use an exponential backoff. So after the first retry, we might wait 100 milliseconds, then we might wait 200, 300, and then 500, and then we'll wait a second, another second, maybe 2 seconds, and then 5 seconds. So this is already like this is already 1 second, 2 second, 3 second. This is almost like 9 seconds already. So by this point, 9 seconds is a lot of time. And if they haven't already, if the resource isn't ready by now, then something is obviously definitely wrong. Now, unfortunately, I can't really demonstrate this because I need to build this resource here, which I can't do yet. So let's go ahead and do that. Actually, let's open a new terminal window. And then I will make a registration resource folder, cd into it, and then I'll build a project skeleton for this. One moment, please. Okay, I'm back. I've just set up a basic bare bones project skeleton for our registration resource. We've got our gem file, which is referencing the gem spec. Under gem spec, we've got our only dependency so far is rack and a test framework. Now let's go ahead and install gems. Now I install gems a little differently. I use a script, and let's go ahead and do that. And since we're just installing rack, there's not that many. It's not that large of a dependency. Now, the thing about rack is that all you really need is this config.ru file or rackup file, and you can basically pass in. Let's do here. Let's say you want to just do a basic hello world example. Okay, when you let's call this. We want our environment file, and we want to, I don't know, return a response of 200, and we want our headers to be content type text HTML, and we just want to say hello world. This is the expected response for any sort of rack application. All right, so we just say app equals hello world dot new, and then we run the app. Now, let me run this. To run this, I'm going to need a to use a web server, and what I use nowadays is Falcon. Let's install that. There's a lot more that was installed. And then we want to set our dev script here to now what I usually do is the way you start the server is you do bin falcon serve, and we bind it to localhost 992. And the reason I do this is because Falcon by default checks the number of cores on your computer or number of threads on your computer, and launches a number of processes or threads equal to that number. So I just want one thread. And now let's clear that and run. Oh, right. Bundle bin stubs Falcon, of course. And there they are, Falcon. Yeah. All right. Now let's run the server. Okay, it's running. Let's open up my browser. Okay, we've got our single page app here, and now let's open up. Yep. Okay, here we go. Hello world. And just to show you that that is correct, what we're expecting, let's change this up to hello world with rack. Okay. Let's go up here, run the server, open up my browser, and refresh. There we go. Now, as I said before, the reason I use rack, or the reason I'm using rack here instead of, say, instead of Rails, is because rack is used in basically every single Ruby web framework. It's used in Rails, it's used in Rhoda, it's used in Sinatra, Hanami, many others. So what I find is that knowing rack will allow you to use any rack middleware or application and then use that anywhere in the Ruby ecosystem. All right, so we've got our rack application, but I kind of want, I'm not, even though we want to use rack, I don't want to use, when we're doing routing, like say we're going to say some foo route or some bar route, I don't want to really use rack for that. I want to use my own, I want to use a router, some sort of routing code. And what I like to use is Rhoda, but I like what I mean is I like Rhoda's API, and not necessarily like they have a bunch of other plugins and stuff that I don't really use. So what I will do is my own pull in my own router, and I realize now that maybe you won't be able to use this or follow along because there are certain things that I'm using that aren't available. But maybe I'll make them available before this video goes out. So who knows? Anyway, so I have so I'm going to install this, but it's not really available anywhere right now. So what I can do is go here and set the path to this directory. And if you look, I have a number of my own personal libraries that I use, and I'll go into them. I'll go into more detail with them at a later time. But right now we're using Router, which has a Rhoda-like API. So, oh, actually, I need to install this. Cool. Now, so what I'm going to do now is let's go back to our config rackup file. We don't need this anymore. We want to run registration resource application. Okay, well, that's not been defined yet. So we'll define that here. And we need to load it here in our loader file. So we will require registration resource application. Okay. So okay. Let me go back to the loader file. So here we need to actually load all of our libraries that we're using. So we need to require rack. I also want to require the router that I just installed here. Otherwise, it won't be available. What this does is that it has a router module that you can include. And with that, you can set, much like in Rota, the routes. So you can do r.is. Let's do the same hello world thing we were doing here. So so we just return 200, return header, content type, text, HTML, and then hello world from router. Okay. Let us run that. Oh, there's an error here. Initialize constant registration. Let's see what's going on. I know what's going on. I need to require the init file. And that's just this file here, which is part of the, and you can look at that in the code later. Nope, okay. What is making this error out still? Require relative init, and then require load path registration resource application module registration resource application registration resource. Oh, I think so I think what I need to do is do the same thing I did before, which is, and then run the app. Yeah, okay, there we go. And let us go to the browser and try again. Hello world from browser. Uh-oh, I see there's an error here. Let me see what's going on. Uninitialized constant registration. All right, I'm back, and I guess I figured it out. Let me guys open up my browser. Actually, let me open up the server. So, as you can see, there's a 500 error whenever the server tries to load the fave icon. And we don't want that to do that. What I usually like to do is go into the config.rackup file and set a 404 response and just run that here, and then run this as middleware. But it's not a middleware. It's so we're gonna have to define. We're gonna have to define that. So what we do is go here, add that. Let's okay, and now we'll go here. What registration resource All right. This is the middleware that's being initialized in a rack application. And then this is our actual application that we want. And then each middleware needs a call with the environment as a variable. And then we get the response from our application. And if the response is nil, we just go on to the next middleware. Otherwise, we return the response. Let me just check to see everything is great. Okay. Let's run that, and let's open up the browser and see if everything's good. All right, cool. We're still not getting a favicon, but the instead of a 500 error, we're getting a 404. And if we go back to the editor, we see that there was no error. Excellent. Okay. So the reason I'm using a Rota-like API is that I kind of like this syntax. You can do a bunch of things, like you can separate out get matchers. You can also separate out post matchers. You can also do things like is foo. And let's actually try that. Now, the reason I'm not using Rota itself is that Rota's syntax requires that the last thing you return is a string. And I prefer to work in Rack's API for this kind of stuff, because I get to have precision. I get to determine what my headers are and what exactly is returned in my body. Most of that stuff. So let's kill that and start the dev server again. Open up my browser, refresh, cool, and go to the foo route. And here you go. See? Cool. Let's go back to the editor. Kill that. So I just think this is a better way of working for me, and maybe it's not for everybody. So, if you remember the API we kind of sketched out earlier with when we were on the single page application, basically we're doing a post to some resource. I think we changed it to just this. And then we get that resource. We query this resource until it's no longer returns a 404 response and returns an HTTP 200 response with this body. Okay, so in order to get there, we need to capture a post. So another thing I like about the Rota API is that you can use Rack Builder. So I can do this to do middleware stuff, and use this to build whole other Rack applications that are nested within the within these routes. So let's go ahead and do that. Let's see. I have a library that will allow me to parse JSON into, well, actually, let me just demonstrate it. Um, um, okay, so let's do that. Okay, we're basically printing out the parameters, um, and let's run the dev server, and let's go ahead and let's try to curl into it. So let's do, we need to set the content type, set the data that we're sending. Let's just do this for now, keep it simple. Oh, I may have made an error here. Oh, right, I need to actually set the parent. I'll do this. Okay. And then I'll go here, clear that, go back here, and then go here, and then we'll curl again. And we go back here, we print out, there's nothing that is printed. Interesting. I would have at least expected something to be printed because we're sending in a payload. Oh, I know why. I didn't set the type to post. So let's do that. Nope. All right. After some digging around, it seems like I didn't program uh, my router to actually expose that data. So what I'll do instead is just do this the long way. All right. So what I'm going to need to do is create a rack application in here, and we will just run, I don't know, a test.new, and we'll put that right here for now. Okay. So what we're going to have to do here is, so this environment variable, let's actually just print this and see. Let us see what that does. Oh, I'm going to need to curl. What was it? Was it post? Yes, it's post. Okay, and then actually, I don't think I need any body. Oh, actually, I do need. I do want to set a body. Okay, and then yeah, let's see what happened there. Test. Okay, let me see if that is registered. Yeah, okay. So when, oh, I know what I did wrong. I didn't actually tell the router to run the rack application that is defined here. So what we need to do is r.run app. And that's just a holdover, a holdover from a vestige from Rhoda. Let's do that again. Okay, so yeah, here, whoop, that's weird. Yeah, I guess I'll have to use my keyboard. So yeah, here is the environment, the rack environment that is passed in, and this is actually available in every single web framework that uses rack under the hood, which is all of them, if they're Ruby. So what we need to do here is to what we want to do is we don't want to deal with that. We actually want to get the we want to get the body, which is in rack input. And actually, this right here is not a string. It's a stream. Not a string. It's a stream. So what we need to do is we need to read it, and then we usually want to rewind it in case other middleware down the stack want to use it for themselves, and then we can print that. I think hopefully that will work. And there you go. And as you can see, it's an actual string. It's not actually in JSON format or in a hash that we can use. So in order to do that, we'll have to parse it, and then we should be able to see it in hash form. Oh, see, there you go. But I already have something like that. So I'll just install it in here. And I also have it on my local directory. So okay, let's try installing. That seems to work. Let's go here and actually load it up. And the way this works is that, actually, let me keep that right here, so it might be useful. The way this works is that it's a middleware. All right. So you just set the middleware like so, and you set the key that you want to actually set. So basically, what is happening? So let's say this is that middleware right here. It's basically saying some key equals that hash. Okay, and actually, I'll just define that and then do that. So So basically, what this is doing is it is parsing the body of the payload that's sent through the body of the HTTP request, setting it into this key on the environment, the rack environment, and then because we're running this app here, it will print out that key for us to see. Okay. Let's just curl, and there you see. Cool. So now we're parsing the data. We might want to validate it also, but I won't do that right now. Instead, I want to actually do actually want to, instead of defining the class here, I want to define it elsewhere, in my project. So what I'll do is actually let's set this key to, I don't know, registration key. I'm horrible at naming things. And then here, now what I like to do is use this pattern where so the problem with the some when you have these Ruby objects is that when you're testing them, you have to there are certain dependencies that each of these each class might have, and unless you actuate each of those dependencies, like like build them up by hand, usually there you have to have a fully operationalized class with all of its dependencies operationalized, and that's not usually what you want to do. Usually you want to, like, well, I guess in some parlances it would be stub them out or mock them out, but I don't want to use a mocking library per se. Instead, I want to use a library called this is from the Eventide toolkit, and it's called EVT dependency, or just dependency. And what this does is for each, well, I'll show you. Yeah, and then I just need to install. Okay, and then I need to go here and actually load up the dependency called dependency, and then we can use a macro called dependency if we include the module. Okay, and what we want to do is we want to set the dependency of the class command. And what this macro does is that unless you operationalize in this dependency, and remember, this is going to call database. This is going to access the database, and sometimes in our testing scenarios, we don't want to access the database because I/O is pretty expensive in a test suite, and we just want to test out like the stub. So what this will do is, unless if this is operational, if this was constructed with application.new, then it knows don't operationalize this with a real class. Instead, use a substitute to that won't actually use a null substitute that won't actually call the interior of the class. So in order to actually operationalize it, Actually, I'll show this. So we've got registration. Let me show that by calling IRB require init RB. Oh, cannot load such file. Oh. So I don't actually have a class called that, but well, you do now. Okay. So we have our register. Oh my god. What is up with this green color? Huh. I'm back. I don't know what that was. So I don't know how to get. I don't know what I did to get my thing, my IRB console like this. But I don't really have any recourse right now. So what I'm going to do is not colorize the output um, and show what's going on. Oh, right. I need to load the require. Okay. So there we go. So we have a registration resource application. Now, I'm not sure if that's what we wanted. Yes, it was what we wanted. So app. So we've got our app. And when we try to, what's going on here? Undefined method. Did I do this right? Dependency registry. Oh, sorry. I'm such a doofus. Okay, so here you can see it's a mimic class. So mimic is Eventide's null class library. And what it will do is it will just no op anything you try to send to it, I think. Sorry. Oh, no, I'm wrong. Oh, I know what. I need to set a method here. Test blah. And let's actually we'll do that. So we need to actually what was the method I used? Oh, test blah. So instead of actually like calling this actual method, what it's actually doing is no-opping it into this mimic void. So let's say we want to actually, you know, operationalize this fully. So what we want to do is, well, first of all, .new will always yield that result because it's not operationalizing it. But instead, what we want to do is we want to define a constructor called build, and we will define a constructor called configure on the command. Now, why do this? Because oh, sorry, I did this wrong. We want to declare a new instance, return it, and also configure it. And so what we want to do there is declare a method where that's where we want to do this. Call this constructor on here. Now, why do this way? This is what we would call the separation of concerns. So the application knows how to build itself and how to operationalize itself, but it calls command, and command will figure out how to operationalize itself. Okay. So what we do here is first we'll set a build constructor, and then just do the same thing. Turn that, and we don't really have any, we don't have anything to operationalize quite yet. So we won't bother with the .configure method. Instead, what we do here is the configure class method will have a receiver, which is the receiver here will be the application here. So see how it's when the application is calling configure on command, it's passing in self, which is itself. So this is the receiver, and this is just boilerplate at this point. Registration command. And what? Okay, so what this does is when the application calls command.configure self, it's passing in itself as a receiver. And what that does is the command will build itself, so it'll call the build constructor, and then it will set the attribute name, which is registration command, with the instance of itself, with the instance of command. So let's look at that and see. So let's we call this. Well, let's look at this one more time, and then test blah. It's just mimic void. But if we call build, and then we call, you can already tell something's different. That registration command has been set with something. We can tell, because it printed test the way we thought it would. So it was operationalized. Okay, so there's that. So what I'm going to do is copy this and put it in its own class. And I'm going to load that here. Okay. Okay. But we don't want this method here. All right. So what we want is we need to set the call method with the environment variable. Okay. And then with that, so we get the input. So right now we set the input as, let me close, whoops. We set the input as registration key. Bad name, I agree, but okay. Remember, this is a hash of the data payload that was sent right here. And so we need to set the registration ID equals input. And then the not user ID, the email address equals input. Just to test this out, we want to print out registration ID. Whoops. Print registration ID and print email address. Okay. And then we will, okay, clear. Run the server and then post. whoops, wrong number of commands given. What's the error here? Did I do something wrong? Oh, whoops. All right. So what we want to do here is we've got command.configure. So registration command, we need to set this as registration command and then run the handler. Mostly because the scope inside here is not equal to the scope out here, so it won't be able to see. Well, actually, that doesn't make sense, but whatever. I know that's what I found to be the case. That looks promising, but didn't print anything. Dear me, dear me. Let me just put something here. Okay. Oh, that didn't work. Okay. Well, let's just make sure that let's see. Oh, I know why. All right. So when we're here in the config.rackup, actually in the middleware, we're not calling .build, we're calling .new. So anything that it's not being fully operationalized. Oh dear. See, there we go. Test foo. This is the registration ID that we set, and then the email. So everything seems to work. Okay. So what do we do with this? Well, if we go back here, we need to return a header location with the location. So let's go ahead and do that. Let us take the rack environment and create a request with it, a rack request. Okay. Now with that, we know the base URL that was called. Just to show you that, here it is. We'll print it out. Request.url. See? And so what we need to do with that, what we want to do with that is right, we want to add the registration ID. Right? So let us, all right, let me close out of this. Cool. See, it's now we have that. But we need to return it. Okay, so let's equals registration ID. Just so you know, let's add a placeholder here for any database IO we need to do. So what we're going to do here, between reading the data and sending response to the user, we need to actually do some sort of database IO, like And we'll get into that, but right now we're just doing the bare bones right now. So let's set the header. Let's declare headers. Content type. Actually, we don't need a content type. We need a location, which will be location. And then we can return 202. Now, 202 is the HTTP code for accepted, I believe. Let me check that. Yeah, accepted. That is the generally accepted response status code that we want to return for something that is going to be processed asynchronously. So we pass in headers and we pass in an empty body. And that should be all we need to do. Okay, let's close the server. Now we want to see the headers. See? Look what we got back. We got a 202 accepted response. We got a header with the location of what we want, and that's what we wanted. That's the API that we set. So we're done with this. But now we need to do this part, the query. So when they query this, we need to be able to know, hey, you know, let's see. So let's do a little bit of refactoring here. And then okay. Okay, here we go. I'm not sure. So I think this is the correct sentence, but I'm not sure. So we want to test this out. Okay. And I'll just curl it. Undefined local method variable. I think that's wrong, obviously. Maybe. Okay, didn't find it. So that means I'm doing better. Oh, well, I mean, yeah. Okay, so that worked. So this is the correct syntax. All right, let's do that. And then r.get. And we'll do something very similar. We'll do something very similar. But let's just see if I didn't break it. Oh, what? Oh, right. Okay. Actually, just yeah. Okay. So clear this, run the server. Oh, I know what I did wrong. I know what I did wrong. All right. So what the problem is that I need to. I did that wrong. And then no headers. Let's try that. So I'm not doing it right. Um, nope. I broke it. That's not cool. All right, let me see. Are not on. Okay. Um, so I know that worked. I'm pretty sure. Okay. Yeah, see, that worked. But I'm not getting the registration ID. Ah, okay. I think that's correct. Yes, there we go. Huh. Okay. Anyway, so I'll keep that. Just so I know that I didn't break anything. Great. Awesome. Okay. So, what we want to do with this is basically what we're doing here. Okay. So, we'll call it query. And let's just copy all this. Paste. Let's do that. And now what we want to do is take the registration ID. Okay, right. So the thing about this is that once you're at this point, the environment, the router here changes the. Well, let's actually let me just check. It's better just to confirm with your own eyes. Yeah, that looks good. And so we'll do much the same. Use this. So let's, I'm not going to use any middleware right now. Then run the app. Let's try this out. All right, so yeah, it worked. We're printing the environment variable. Let me just look here. Let me try this. I think it is. Let me just print those, see what happens. .abc. Cool. So, so it's script name. And let's see. We can do this. We just want to remove the first character. All right, let's check that out. Oh, cool, awesome. Now that we've got the registration ID, okay, we need to actually query, but let's not do that now because we don't have any database sets. We don't have any database set up. So we're just going to add a little to do here. Database IO. Now, what we want to do is we want to set the headers and the content type to application JSON. And we want to set the body to the payload that we originally discussed, this payload right here. Actually, I'll just copy that. Paste. Oh, yeah. And then we'll make that JSON. And then our payload, our rack response will be headers body. And let us see if that works. Cool. Yeah, see? We've got a content type of application JSON, and we have a payload a hard-coded payload that we're returning back. Let's see. So, if I'm looking at this correctly, we have everything we need in our resource to actually test the single page application. So let's go ahead and open up the browser. Okay, yeah, here we go. We're here at the browser. And ideally, wait, I don't think yeah, it's not, the server's not on. So let me just do that. Let me refresh. Okay. Ideally, this should just work. Ah, okay. I had a feeling that this would come. This is a CORS error. So we need to set the access control allow origin header. So let's do that. So we're not setting the access control origin, which is what we need to do if we want this to work. One handy way of doing that is going to our config.ru and setting a new middleware. So we want to initialize our app. And then we want to call with our rack environment variable. And then, so we want to get the response. So if you want to think about it like this, each of these middleware is on a stack. So core, this is first on the stack, then this is second, and then we finally run this, which just, if nothing is returned back here, we just return back 404. But when we actuate the apps call method with the environment, with the rack environment, what happens is this cores, it'll go in here, and then it'll say, okay, get the next middleware on the stack, which will be this one, and then get the response from that. And then if there's like a huge number of middlewares, it'll go through every single one, blah 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 blah. Okay, so now that we have that, we can set the headers, which as we know from our which we know from our is in this format. It's an array with an integer, a hash, and another array. All right. So what we can do is set the access control allow origin, and we'll set that to, I believe it was HTTP localhost 1234, and we're hard coding it now, just because that's easier. And then we return the response. So we'll restart the server and then open up the browser and see what we see. All right, we've got a different error here. So it's still a CORS policy error, but we don't have, it does not have HTTP OK status. What? Oh, I think I know what this is. So if I go back to the browser and I check the network, you can see that it's looking for an options, a request method of options on this request URL. And because it's not returning back anything, because I haven't defined it, it's failing. So let's go ahead and define it. We'll need to go here. And then we will set a response code of 204, which means no content because we're having an empty body. And I believe we need to set a header of allow, and then a list of request verbs that are allowed for this endpoint. Yeah, that should be correct. So let's close this, restart that, open up my browser, and then try again. At least we got something. Let's see, why is this access to request header field content type is not allowed by access control allow headers in pre-flight response. Okay, I'm familiar with that as well. So back at our config rackup file, we need to go here and add another header. Access control allow. Whoops. And then we can add content type. Okay. So that's what I mean. This allows you more fine-grained granular control over the HTTP response that you wouldn't normally get in a web framework. Now, maybe you don't want to deal with this kind of stuff and you want to have it done for you, but I find this to be an interesting learning experience. Okay, let's open up the browser and click register again. Okay. Looks like we got an error. So let's go back to the network. It doesn't seem like. Let's go back to the editor. Let's open up the web folder and just see what's going on here. So we're catching the error registration. So it's catching an error. What error is it catching? Let's go back to the browser. Let's clear this console and try again. Okay. Let's try this. Getting an error. Accepted. Okay, it doesn't look like it's actually pulling the so if we go back to my editor, this part seems to be working fine. It's just this part that's not. So let's go look and see what's going on. I need to actually know if it's getting in here. Okay. Let's open up the browser. Okay, it's not. It's not getting in there. So maybe our retry logic is faulty. I don't think I actually use retry. Has that been there this entire time? Okay. All right. Oh, I never actually showed the browser, the editor. Let's go back to the editor. So here's what I added because I was importing here, and then I was calling retry here, but I never actually destructured it from use retry. Like if we go here, you can see I'm doing this, and then so yeah, it was just a bug, a dumb bug. Okay, let's go back to the browser. Okay. Okay. So something's definitely happening here. Like the get query is working. But it's calling null here, which I don't want. So we're not actually getting the correct headers here. Let's try to see what we see here. Go back here. Okay, headers. Oh, you know what? I know what this is. I know what this is. Okay, let's go back to the editor. So let's back out of this. And then let's go here and back out of this. Redo. Okay, yeah. So the problem is that the security settings are such that when we that the browser won't read any headers that aren't explicitly defined. So we need to define them. But I don't want to define them for all the routes in this resource. I just want to define it for let's see, for the post route. So we will create a new middleware called expose headers. Okay. And then okay. Call that. Let me actually copy that so I don't have to retype everything. Paste. So class expose headers. So this should look familiar in a rack middleware. So we get the response. And we return the response. Before we do that, we want to get the headers. And we want to set the headers access control expose headers to location. And theoretically, that should be it. So let's close. Let's clear this out. Restart the server. Go back to the browser. Okay. Yes, we got a registration successful message. And if you look on our network tab, we can see we are querying this resource here with it, and we're getting a response. We're getting the payload that we want. Is email rejected and is registered true. So, let's just do a recap of what we have done so far. We've created a single page web app that will take an email input, and when you click the register button, it will submit it to our server here, and that server will take the post. Let's look at our thing here. It will take this payload when you post to this address, and will return a location header, an HTTP response with a location header with the location of the resource that the single page application should pull. And if you pull and pull and pull, because of the asynchronous nature of event sourcing, at first the first couple of responses will be 404 responses. It won't be ready yet. But finally, once it is ready, because the resource becomes eventually consistent, messages get processed, so on and so forth. We will eventually get an HTTP 200 response, or I guess, what did we say? Whatever. Yeah, 200 response, and we will be returned this payload. And I think, yes. And that's what we've seen so far. So we built the web UI, a rudimentary web UI. Oh, this is wrong. There you go. So we've built a registration resource. And then next we want to actually start doing something with the database. Okay. So we've coded a bare bones web UI and a registration resource. Now let's move on to the database. And by that, I mean the message store, place to store messages. And this will be the core of our event sourced application. Before, I said that we would be using Eventide, a toolkit to build event sourced components in Ruby. And at the core of Eventide is MessageDB. Eventide is simply a Ruby client for MessageDB. And MessageDB is a message store database built in PostgreSQL. So it uses functions, tables, etc. to implement event sourcing. So how to get this working on your machine? Let's see. Well, first we need to have PostgreSQL up and running. And, instead of going to, let's go to a different window. Instead of going to downloading, say, PostgreSQL, running a copy of Postgres on your local machine, what I prefer to do is instead use Docker to use Docker to run instances of Postgres, because there could be instances where you're working for multiple clients and each client uses a different version of PostgreSQL or MySQL or whatever storage technology they use. And it's helpful for me to keep that all localized to each individual project. And I'll show you what I mean by that. So what I'll do is I'll make a directory called database. Let's cd into it. All right. And we'll create a Docker compose YAML file. Okay. And let's open that up. All right. So what we're going to do here is define a very simple Docker compose YAML file. We'll start with version 3. And then we will define our services. And our service is just going to be the message store data server that will house our PostgreSQL image. So let's define an image. I'm just going to use 12.4. And I'm going to define an environment variable here called Postgres host auth method. I wouldn't do this if this was a production environment because this is a development, and I don't really want to deal with passwords. I'm just going to allow all requests to connect to this database to be trusted. And I'm going to define a volume, and this is where all the database information will be stored on our local machine, mounted to our image. So what I usually do is I define a folder. Instead of using Docker volumes, I define it directly on my local directory. So I define a directory and mount it to this directory on the guest image, var lib PostgreSQL data, and then I'll mount a couple of ports so I can actually connect to it. And here for Docker, it's 5432, 5432. And then I'll save, and then I'll quit. With that, we can just run Docker. So we can do Docker compose up, and then we'll daemonize it. And it should be running in the background. You can tell by doing docker compose logs. Yeah, it's ready. And so that we can connect. Now, with normally, if you have PostgreSQL installed on your local machine, you can just do psql. But because we don't have it installed on a local machine, that's not gonna work. It's gonna say there's no such server running. So instead, we need to actually specify the host. And I just use 0.0.0.0. And now my user name is not a role on the database. So let's just use the Postgres role. And we're in. And we don't really have any tables or databases defined, you know. So, but we have PostgreSQL now. We're able to use PostgreSQL on our machine. Now, if I wanted to, I could go in and add more servers to this Docker Compose file. Like more databases, but I'm not going to do that. But you can see that this can be very versatile in using different versions of Postgres. And if you want to see where the actual data of the Docker image is stored, remember we mounted a volume from our local machine. So you can see the .database message store folder, and that is where we're storing. That's where we're storing all of the information. So we have PostgreSQL running on our machine through Docker. Now we want to install MessageDB. And MessageDB has several ways you can install. You can git clone it, you can use a Ruby gem, and you can use npm module. I'm not going to use any of these methods. I will demonstrate the Ruby gem though, but I'm not going to use that in our project. This is simply to show you how to do it, but I'll show you why I do it, and I'll show you the way I do it and why I do it that way. But let's see the Ruby gem first. So let's go to our we have a Ruby project here. Let's see. All right, so we have our project. We have our project here, and we have a Ruby project. And I'll go ahead and install MessageDB. And this might be how you install it in, say, your Rails project. And then I will run install gems. All right, so MessageDB is installed. So let's go back to the Git repository. You can see that from the executable, you can run certain commands to create the database. So let's go ahead and do that. Let's clear this out. We can do bundle exec mdb create db. All right, so we're running the same problem. So how do we get around this? We can use, let me get some more space. So we can use Postgres environment variables. So you can define, say, a pg host 0.0.0.0 and run your original script. All right, and same thing with this. So we'll do we'll do this, but we'll also define the user. And you can see that the that the database has been the database script has been installed, and we can see this by going into our PSQL and going into the message store database. And now we're logged into the message store database. We can go ahead and see, say, I don't know, the schemas, and we have a public schema and a message store schema. We can look at the database tables, and that would exist inside the message store schema. So we'll go to the message store schema, and you'll see we have one table called messages. All right. So let's look at that table. All right. So, well, of course, there's no actual rows here, but we can look at the look at the schema for the table by doing message store messages. All right. I don't know if this is readable. Let me look at that. Okay, there we go. It's a little bit more readable. So you can see there are a certain number of columns, and there's a certain number of indexes right here, and you have a global position, which is really a big serial. There's a position, time, stream name, type, and we'll go over this a bit later when we can work with actual data. But like I said, we're not going to be using the message store DBs, message DB scripts. And one thing you may not know is that if you look here, all these really are what all this is this install script is basically a bash script to install various PostgreSQL scripts onto the database. Like, say, if you look at the table, it's just a SQL script. It's just a create table for this messages table. And the reason I don't want to use their installation script is because there may be certain things that I want to do for my own projects. Like for these roles, I don't want to use their message store role. I want to use my own personal one with my own permissions and so forth. So, with that said, let's go ahead and do that. Now, because we've already run the installation scripts, what I like to do is just stop the container for the database, remove the database directory. All right, and you can see it's no longer there. And then just turn on, spin up the Docker containers once more. And as you can see, there you go. So how do we do that? Let's go back to, I have a project called Database Message Store. And all this is I I just take all the SQL scripts from the original MessageDB project and modify them for my own needs. And I use Skitch as a change management tool for my database migrations. If you don't know much about Skitch, I suggest you take a look, but I'm not going to go into much detail here. Here's the link if you're interested. Anyway, let's go back here. So, yeah, let me see. A couple of interesting things about this project. It's got all the list of the migrations here, like you would find in a like say a Rails project. You've also got a couple of you've got the targets, which Sketch uses to know where to where to run these installation scripts. So I think you can just do. Oh wait, no, we have to. So before we do this, we have to actually run. We actually have to create the database. So let's go ahead and do that. So it's fairly simple. You just do create db, and remember we have to define the host because we're using a Docker container. Let's define the. I don't think we need to define it. We define the user as Postgres, and let's say we want the database to be called message store. All right, so the database is created. We can see that. 1 second. I don't know what just happened. Okay. All right. And let's connect to message store. And we're connected to message store. All right, let's quit. And now let us install the scripts. All right, I think I need to set these targets. Oh, these might be wrong. Okay, let's try that again. Yes, all right. Cool. So as you can see, all these scripts got run, and we can execute pSQL to this database. And let's go look at our schemas. Oh, we've got a message store schema, and we've got a Skitch schema. Now, this Skitch schema is just used by the Skitch tool to track which migrations were run, what the dependencies were, and so forth. So, but let's look at the message store table, the messages table. Oh, and it's pretty similar and straightforward. All right, so that was pretty simple. Let's go see. So we've installed our database, and next on the queue, we want to create a registration component. That is a registration to a component to keep track of our registrations. And let me go ahead and set up a project skeleton. Close this, 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 close. Okay. Let me get rid of this. And go back here and just reinstall everything again. All right. All right, let's go back to our folder and create a registration component directory. Go to that directory. Let's initialize our Git repository. And let's add a project folder. Let's go here, our registration component. Okay, cool. And I'll be right back as I set up this project skeleton. Okay, we have a project skeleton. Let me actually go commit this. 1 second. Okay, now let's go ahead and install these gems. Oh, my project skeleton is incomplete. Okay, that should be. I wonder if that's fine. Let's try again. Oh, yep, that seems to be working. And all our gems are installing. Okay. Now, this isn't quite yet ready to use. And that has to do with the changes that I made. Actually, let me pull those up. The changes I made to the message stored database on my own personal project. So let's take a look at that. We'll add that project folder. So one of the major changes I made was to this role. There are two roles that I'm interested in particular: a reader role and a writer role. And as you can imagine, this role, the reader role, is given specific privileges to only read from the database. So it only has access to the reader PostgreSQL functions, get category messages, and so on and so forth. Whereas the writer has access to only has access to writing messages to the database through this function. And that was done also by changing the functions in such a way as to only hold on. Where is it? Oh, by changing the security to definer. So normally the security is defined to invoker, and that is the role that invokes that function. So if you have a this is what it would normally be, but if you define it to definer, then it's the role that defined the function in the first place. So we have an owner role that defines all these, that is the owner of all these functions, and then any role that has permission to execute these functions will get the same permissions as the owner role. It will be as if the owner role was running this this function. And anyway, so now these roles aren't roles that log in, so you can't log in with these roles. So we have to define roles that inherit from these roles so that we can log in. So let's go set up our sketch project. Okay, there we go. So let's make a directory called, say, database registration service. Whoops. We'll initialize. Okay. Let us add this to our project. Okay, awesome. Okay, let's just consolidate this a little bit more. All right, so we have a project skeleton for our Sketch project, which is just going to add our database stuff. So what we want to do is we want to add a Sketch migration. And to do that, we just do sketch add. We want a role called registration component. So let's add that. Roles registration component. And this is, we add a message. Let's add a message role for registration component. Okay, and it was created. And as you can see, it created several SQL scripts. One to deploy it and one to revert it if you, in case you want to do some reversion, and one to add some verification. And here are those scripts. All right, so let's add our actual role. Okay. We will create the role registration component. Create role registration component login and inherit any permissions. Then we grant the message store reader to the registration component because we want to be able to read messages from the message store. And we also grant message store writer to the same role. And then we alter the role registration component, and we set the search path. This is very important because the Ruby client, Eventide, normally if you don't set this, you would have to say do select statements like with the schema in order to get access to the messages table. By setting the search path, we don't need to do that. This will work instead. Select from messages. Because the Ruby client Eventide only selects like this without the message store schema. All right, so we need to set the search path. So this is what we would use in our deploy script. For our revert script, we'll just drop the role. Actually, and then let's see, to verify the role. This is kind of like what I like to do. I just use I just do a select statement and from PG roles. Okay. And if we do sketch deploy, oops, this is something right here. Yes, there needs to be a line in between this block and any migration lines. So yeah. So let's do sketch deploy again, and you can see that it deployed that change. Let's see if we do pSQL host 0.0. then message store. We're logged in a message store, but we don't have any access to the messages tables, I think. Yeah, permission denied for messages tables. But we do have access to the functions. I can show that. 1 second. Let's say you want to do there's no data in here, so it doesn't matter what I do. Oh, I see. I need to do single quotes. Error must be a stream name. Oh, okay. I think that's because stream names exist like this. There needs to be a dash between the category and the stream ID. All right, yeah. So you can see they have access to the functions, and I think you can say you want the list of the available functions by just doing this. No, is that not right? Oh, here we go. Yes, here we go. Yeah. Anyway, I digress. So we have our registration component role now. And all right, so we have that. And now we can define the Eventide project uses a JSON file rather than the Rails way of using environment variables in order to do settings. So we just get this, and we replace this with our role. Okay, and then I think we can just run the test. Oops, cannot load. Oh, of course. All right. Is that going to stop you from complaining? I sure hope so. Cannot load. Oh, so we need to actually set the posture in order to install to develop. We need to set the posture to development when we're installing in gems, and then all of our gems into the test group will be installed as well. This can be seen when you look at the install gems script. Normally, if you don't set a posture, then the operational posture will be used by default, which will install gems without the development group. So you need to set it to something else. I usually use development or dev or whatever in order to install all gems, including the ones in the development or development dependencies. So with that done, we can test. Cannot load such file. Okay. Well, let's add that. Right. Oh, okay. We need to actually require certain libraries. I swear I did this before, but I seem to be lacking in my notes. So let's go here and require Eventide Postgres. And yes, okay. So our first test works, which is just a database connection test. And if you want to see that, all that does is connects to a database session, and then executes select one, and then if it doesn't raise an error or an exception, then that test passes. All right. So we are well on our way. we're well on our way to actually writing a component. We've got a message store database. We've created a role specific to this component to that database. All right. So usually what I would do when I'm coding a component is that I would start first on the entity. But since we're coming at this completely blind, like we're coming at this as if you don't know how to build event sourcing systems or components, that may be a little bit confusing at first. So maybe what I should do is demonstrate how the message store works at all. And to do that, what I think I'll do is I'll write a test script. So we'll do test RB. Let's see. Let's write that in the interactive test RB right there. And then we will require interactive init. And we'll start by writing a simple message. And since we're in a registration component, we'll write a register message. We'll include a message module, and then we will define a couple of attributes. And these are the kinds of attributes I would expect to see in a message for registering a user and their email address. So let's go ahead and define the attributes on our own instance of a register message. So we got our registration ID. We'll just say ABC. Whoops. User ID we'll say is 123. Email address is jane@example.com. And we will define time as an ISO 8601 timestamp. So something like colon 00 colon. There we go. All right. And then we'll just build a message and define it. Okay. And then we need to write the message to the message store. And you can use this writer messaging Postgres write and actuate it with the call method. Write the message to it at this stream name. Now, what stream name are we going to be using? You can derive a stream name from this little helper method, messaging stream name dot command stream name, because we're writing a command. Register is a command, and event is so there are two types of messages generally. A command is telling a component to do something, and an event is something that took place as a result of that command or another message. So command stream name, and we set that to registration ID, and I just use registration. Okay, and registration would be the stream name. the category of well, I'll go into that. So I think this is done. And now we can run it. And according to this log message, it wrote a message of a command type register at the stream name registration :command dash abc at position 0. All right, so let's actually look at that. Let's see. All right, so we are actually so we're at the message store database. We're logged in. And we want to look at the list of messages. So let's just do a select star from message store dot messages. Oops, the paging is a little bit weird. So let's just turn this on. Okay, that's a little bit better. All right, so here you can see data has a bag of attributes, a JSON. It's a JSON B column, and it has time, it has our user ID, email address, and registration ID. You might notice that all these attributes, they were snake case when we inputted them, but they're now camel case. Eventide translates these attribute names to camel case, just as an FYI. And our stream name is registration :command dash abc. The type of the message is register. Now, so what a component is supposed to do is pull the message store for this table at this category. Registration :command is the category, and registration :command dash abc is a stream name. So ABC refers to the specific stream name associated with this registration ID. The category is the entire grouping of all registration command messages. So it could be ABC, EFG, blah blah blah, so on and so forth. And so it's trying to pull all messages in this category. And then it reads these messages. Like, let's say we go to here, and we were, whoops, wrong. I wanted to go into test, interactive test. And let's say we want to change this to EFG, and we'll write another message. And then we'll log into PSQL, and we'll do the same here. Whoops. Okay. Ignore the second message here, but let's go here. We want to pull this table for all messages in this category for ABC and EFG, and then process them. Okay. And we'll process them in order. So global position 1 will be processed first before global position 2, and then before global position 3. Yeah. And so that's a little bit about how it works. You're writing messages to the table, and then a component or Ruby process somewhere reads those messages and then processes them in order. All right, let's get out of here. Oh, actually, let me just truncate table message stored. Oh, restart identity. There we go. And then it should be empty. Excellent. All right. Let us get out of here, and actually now let's start coding the component itself. And like I said before, I like to start with the entity, or in this case, the registration entity. Why do I like to start with the registration entity? Mostly because the major class functionality, the major functionality falls within this class. Not the message processing, but the business rules and the business rules related to registration or whatever this component is about. Mostly falls under here, and it's really good to get that ironed out before we move on to message processing. So let's define a registration component namespace, and then our entity registration. Actually, you know what? I guess I'll write some tests. Let's see. We'll write automated tests. And what we're trying to do here, this might be a little weird. Actually, we'll just start here, just so you have something to look at. And we'll include schema data structure and define some attributes. Here's an attribute. We probably also want user ID and email address. Let me get rid of this script. I don't need it anymore. All right. So we've got some basic attributes that we probably want. And then we need to keep in mind that registration or any kind of event source component is at its heart a business process. And business processes are very concerned with when things happen, like when a user is registered. And so that is something we want to record definitely. And we will define it as a time. And then we need to have a way, we need to have a predicate method or a query to be able to let other classes know when a registration is registered. Because, they could like just access this this attribute directly, but we want to have a specified API so that there's no confusion. So let's go ahead and do that. Let's define a predicate method for registered, and we'll define that as any registration is registered if this registered time is not nil. Okay. And I guess I'll write a test for that. So we want to, there's really only two cases where we need to test whether registration is null or not. So we need to say, we want to test whether this registration has a register time. And if it does, we will return it's registered. So, and then we want to test whether does not have registered time. And then we want to test that it's not registered. Okay. Now, and define. So we need to do require registration component registration. Okay. Now we could do this in such a way as that we just say registration equals registration null new, set these up. But we would have to do that. We would have to repeat that for every test we write. And we don't want to do that. We could use what are they called? Fixtures um, or whatnot. But what I like to do, what I like to use instead are controls. What are controls? They are, I mean, I guess you could say that they're first class objects that are exemplary of the class that they are of, um, and they don't use database I/O like fixtures would. So you're not constantly querying a database when you're running your tests, which adds time. Say you have like hundreds of tests that all of them are like contacting the database, then that kind of delay is going to add up, make your test suite run super long. So we want to add a couple of controls, and let's just I guess we'll just do that. Okay, we'll add them in the controls folder. Here we want to define. Actually, we'll just do registration.rb here. Okay, and we want to say registration component module controls, doing appropriate namespacing, and then module registration. All right, so we want an exemplary model. So basically what I want to just say, registration equals registration component, registration.build. We're just building a normal everyday registration object, and we want to return it. And then we want to set the ID. Here we'll just say ID right now, and we'll define it later. Here we'll do def self.id. Whoopsie, def self.id. ID.example increment, and we will increment by 11. Okay. And this class is a oh, I forgot to add it. So this class we get from other controls, and we can just set that. This is a control class from this library that is a dependency of the Eventide toolkit. So basically, what it's doing is there's a like a test value here, and we're just incrementing it by this so that we have some sort of unique ID. It's going to be the same value every time. And then, so we have our exemplary example here. If you remember in the test, we want to be able to have two different use cases here. If we want to be able to say, we want to have here, a registration could have a registered time or not, or it could not. Could have a registered time or it could not. And right here, we defined a case where it doesn't. So let's just reference that example. So controls registration.example, and then we want to say it's not registered. So we want to refute registration.registered. The predicate method is true. And here we want to do the exact opposite, right? We want to assert that it's true. But we don't want to use the same control. We want to have different controls for different test cases. And so to do that, we just define a different example. And that can happen down all the way over here. Okay, and then we just do the same thing. But interestingly enough, we don't have to build a completely separate registration. We can just reference the same example and return that. Okay, and then we just set register time equals. Here's what I like to do is, like the identifier, I like to set the time with some controls here. So I'm just going to copy and paste this from a different project. Okay. And then I will say, hey, register time equals time effective raw dot example. Whoops. Okay. Let's go. I think we have to define these right here. They're not being loaded yet, so we need to define. We defined it times. We need controls from the clock library. We also need controls from the identifier library, and then we need to define the controls we just defined. And then we want to require load up the entity that registration controls. All right, let's run the test, I suppose. And we have a handy dandy test script. That doesn't seem to have worked. Undefined method from. So one of the tests worked, but one of the tests did not. And I have an inkling I know what happened. Yeah, I didn't define it. So let's use the ones that we just define. This is registered. This is just a normal empty registration, and this, so it doesn't have registration time. And now it should work. And now you can see that the test passed. So let's go back to our entity, registered time. Now, I think this is enough to get going on. I mean, there's obviously, we haven't actually done any email uniqueness, but I'm not sure that's actually necessary right now. I just want to get this up quickly and running and show you how a component looks when it's running. So let's go ahead and do that. So we have because this is something that you guys have never seen before, I will just do this. I will write the code first, and then I'll write tests later. And maybe I won't even show the tests. But you can always look at the Git repository online and see the tests there. All right. Okay. Okay. So we've built an entity for our component. And the next thing I usually like to build is the projection. And that's mostly because let's see. That's mostly because it allows you to see how this entity is being populated by certain events. So what is a projection? So when we have our entity here in our inside of our component, and if you think of the message store, it's a sequence of events. Or if you think of a stream within that store, it's a sequence of events related to that entity. So if you have the stream registration ABC, this is the stream for the registration entity of ID ABC, right? And it could have all kinds of events, but for now, let's just consider that it has a single registered event. And this registered event will be used to populate this entity. So at the beginning of this stream's lifetime, it may have 0 events, and therefore it will the registration entity will look like something like this. Like you've got your ID, that will be nil. You've got your user ID, that will be nil. You've got your email address, that will be nil as well, and then registered time, also nil. So that's when we have 0 events. But if we have when a registered event is written to that stream, suddenly we'll have other state, and with that we can finally have data in there, and the registered event may make the registration entity have I don't know, 123 email address, example.com, so on and so forth, equals some time. Okay, so let's go ahead and work on that. And for this class, we include entity projection. And also, we want to include messages events. Actually, okay. So when the reason we do this is because we're going to house all of our events inside this namespace or this folder. Okay, and when we're referring to them, we don't want to have to refer to messages, events, registered. We want to be able to just refer to the registered event. And so that's why we include this module. So let me go ahead and add this here. Okay, and we have registration component. We have module messages, module events, and class registered. And then we will go ahead and include messaging, message, and have a couple of attributes, which will be registration ID, user ID, and time. Oh, also processed time. Now you may be wondering two things. Why do we have both time and processed time? So when we have events, we have the effective date and we have the process date. The effective date is like what time is recorded when the user submitted the register command to the stream. And then the process time, so that's time. And then the process time is the time at which that register command was processed and converted into a registered event. We generally want to use the effective date for our business operations, but there may be cases where we want to know, hey, when was this message processed exactly? Okay, next. Actually, let me pause for a second and truncate the database. Truncate table. Excellent. Okay, so we have our event. What I want to also do is create a control for this, because otherwise I would have to build the registered events and assign data to it. And I want to actually just do that automatically without having to think about it for my tests. And you may be wondering, well, hey, why not just use like, I don't know, fixtures or factory bot for that? And because I don't want to use the database every single time I want to test something with an event. So we'll have a registered event control, and we'll add that here. Component controls events registered. Okay, and then registration component. Module events. Module registered. And then we'll make a class method example. First, we will build our event. Whoops. And then we'll return it. But before we return it, we'll go ahead and set some data to it. Equal. Let's see. Do we have ID? Yes, we do. We also want user ID, and we want to have a user ID there, but we don't have one. So let's define it. And then, whoops. Okay. And we want to increment this. But we want to use a different increment than the one we have defined. Sorry, here. We're using one here. Let's go ahead and use ID increment 111. Okay, let's close that. And so we have that defined. And then we want an email address. We'll define it in here inside the registration control. So we'll update this. Right, and then we'll use it here. And then we need time. And we have a time control. And we'll use effective time. And then for our process time, we will have processed. Right. So earlier I said there were two things. Why is there time and process time? But the second thing is why is time recorded in string on the event and as a time object on the entity? Well, that's because on our event, we're reading from our actually, let me show this. Let's go back here and let me see the command for the table. So we want to look up message store.messages. Whoopsie. Okay, so we have this messages table. The data in this messages table is stored as a JSON B column, and JSON doesn't have a conception of a time object. It stores, you have to store your date time objects in a specific format. And what we'll do is use string, and we'll store our time format we'll store our time objects as format ISO 8601, and then we'll convert it to a time object when we're parsing it into our where is it? In our registration entity. I hope that makes sense. So this control looks good. Next, we'll go into here again, and remember I'm writing the code out first so that you can understand what I'm doing, and then writing tests later. Here we use an entity name macro for registration. This basically allows us to assign attributes to the registration as if we had defined it as an attribute in the class of projection. And then we have a block called apply registered, and it takes a registered event argument. And what we do here is we use the entity registration, and we just set data here from the event. What I like to say a lot is that software development is nothing more than moving data from one place to another, and that's really what this is that we're just moving data from the event to the entity. And so we can move all that data here. User ID, email address, and then the registered time from the registered.time attribute. Whoops. Okay. So as you can see here, we have our registration entity that's used here, and we're applying events to our registration. And applying events means we're setting the data from that event and using it in some way, and applying it to, and using it in some way on our entity. Let's go ahead and redo it. Let's do a test. Okay. So we need to require our init file. Whoopsie. So we have our registration. Let's open up, and we've already got this control defined. We already have this control defined. Actually, no, we don't. Okay, so I'm going to have to define a new control where there is no data set, like it's an empty registration, because this one has registered time set, and that's pretty much, and this example has ID set. So we want, let's see, yeah, like this. Right, okay. So we want to say new.example. Okay. And let's just make an assertion that, hey, this registered time is nil. And let's get an event from our controls. And this is what we just defined. And then let's make sure, we want to make sure that these are defined as well. And let's do this for all of the attributes within this event. Okay, and then we create a projection with this registration registered. So this is what this does is it actuates the projection with this entity, this empty entity, and applies the registered event to that entity. And then we'll be able to make tests on the entity. So here we can say, hey, was the ID set? And we can assert that the registration ID equals the register.registration ID. We can test, was the user ID set? And we can go on down the line. And then we want to test that the registered time was parsed correctly. Okay. And actually, we can go ahead and run this test. Uninitialized constant projection messages. Okay. I think I know what happened. So we've defined this here, but we never actually defined it here. So we need to load this up. And then let's test it. Ooh. Oh, did I do a little typo? Yes. Okay, is not a kind of time. Oh, did I not parse it at all? I did not. I see. All right, so I want to parse this time before I set this. All right, let's run this again. All right, yeah, that seems to have worked. All right, so we have our projection. It's fairly simple and straightforward. Next, what we want to do is our handler. So let me set that up. Okay. So we have our handler. This is one of the more complicated pieces of the component machinery. And I think it helps to understand what's going on here. So you have your message store, and you have a sequence of events as a stream that are read by our component. So those messages get passed through to the handler. And as you read each message, as the handler reads each message, they need to do something with that message. They need to process it. Okay, and that's what the handler does. Is that they process messages. Usually, what they do is they take in commands or events and process those messages and create new events into the stream that they're concerned with. So let's get started on this. So we want to include a couple of dependencies. Whoops, Butterfingers. Okay, let's see. So we have some modules that we've included. We also want to define some dependencies. We want to define a write object, which will allow us to write messages to the database, our message store database. We also want to define a clock so that we can have a mechanism to record time. And then we want a store. And that's a class that we'll define. Well, let's go ahead and add it here. Okay. So we have our store, and this is used to fetch entities from the message store. How does it do that? Well, we have our category of messages, registration, and this can include streams like registration-abc, registration-def, or whatever ID we have. And then we populate registration entities. Okay, and we're using the DSL from this entity store module. And then we populate those entities with projections. Okay, and we read those messages from the message store with a class that will let us read messages. And this is our store. And this handler will use this store in order to fetch these entities with this projection. Okay. And then we want to we want to define how those how these dependencies are configured. So we want to define we want this class to be able to know how to define its own dependencies. So we just configure it like this. And like so. And like so. Okay. And then we want to say, hey, look, the category in question here is registration. And we want to be able to handle any register command that comes in and do something with it. All right, actually, let's go ahead and define our register command. And we'll just copy this and paste. And it's pretty much like this, but we don't have a process time attribute. And in that vein, wait, let me just load this up. Right here. Excellent. And then let's go to our controls and do the same. Cool. And then we want to go here. Whoops. Okay. Register. Cool. Okay, close that. We don't need this. We don't need this. All right. So we've got our register command, right? We want to take that at its most basic. We're just basically saying, hey, let's get time here. And our stream name. This stream name macro comes from this this module right here. And this will take, what this will do is it'll take the category and add the registration ID to it. So we want to take our register.command and come here. Right. Okay, here we go. So we've got our registered event because we've copied what this follow method does is that it's a helper method to copy is to have create a registered event and copy whatever attributes are in the register command over to this registered event. So right now, if we look at the command here, we've got registration ID, user ID, email address, and time. That means the registered event will have registration ID, user ID, email address, and time, but process time will be blank. And then that's what we're going to set next. And then we want to write to this stream name. Okay. Now let's go ahead and let's go ahead and open up a Ruby console, and then let's take a command. Actually, right, this works. Let's take a command. Okay, so we have register, and that has a registration ID. Okay, let's take a handler. Let's see. Oh dear. I didn't. Oh, okay. Let's go back into our console. Let's get this again. And then let's build a handler, and let's go ahead and see what happens when we handle this message. Undefined local variable name, method, registration ID. Oops. Right. Okay. Well, okay. Let's say registration ID equal register dot registration ID. Cool. So we've got our register command, we've got our handler, and then we want to handle that command. And if we see here, what's returned is the command. But if we go ahead and go to if we open up PSQL, let's select. Well, actually, let's turn this paging on, and then let's look at the messages. And here we see, yeah, a registered event was written to the message store at message at stream name message registration dash whatever this UUID is, and a process time was set from this register command. All right. Now there's a problem with this, because if we handle the same message again, we're going to get duplicate events into our message store. See, we're getting in global position 1, we're getting a registered event with this user ID and this email address and this registration ID, and in the exact same, and in global position 2, we're getting the exact same message, perhaps with a different processed time. And that's not good. We always need to take idempotency into account when we're dealing with event-sourced systems. Really, you need to take idempotency into account when dealing with any kind of system. If you ever had an instance where you have an application that says, "Hey, don't click on this button twice," or you have an application where a button is disabled once you click on it. These are that one, you have a system that isn't taking on the first case, you have a system that is not taking idempotency into account, and in the second system you have the client trying to fudge a way to handle idempotency without messing things up. But really, it's the server that should be handling idempotency, not the client. So let's go ahead and truncate these messages. and we want to handle item potency now. And that's where this store comes in. We have to fetch from the store our registration entity, and this is what we're getting. Okay, this is how we fetch this is how we fetch an entity from the store, and it looks very similar. It looks very similar to, like, say, an active record find method, um, optimistic locking. If we look here, each message has a global position and a position. Now, the global position refers to, this is basically just a primary key or a serial over this entire table. So regardless of whether the stream is registration dash ABC or registration dash DEF, the next message written to the message store will be 2 because the global position is 1. Now, every message also has a position, and this position is unique to this stream. Okay, so you can have multiple messages with position 0, but they'll be in different streams. So let's, if we wrote a message, let's say this is the stream registration dash ABC. If we write a message to registration dash DEF, then the position will also be 0 because that would be the first message in that stream. But if the next message we wrote was registration dash ABC, then the position would be incremented to 1. And so, because we know that the position will always be auto-incremented within the stream, we can use that as a sort of version number. And in fact, Eventide will allow you to retrieve the version number, which is basically the last message within the stream. And when you have this version number, you can use this to make a check on your write that you want an expected version number of what your last version was. And so what this method will do with this input, it'll check the message store. What is the last position or version of my stream? What is the last message? What is the last message's position? Okay. And so let's take this. Let's truncate here. Okay. And we'll take store.fetch register.registration ID and then include version. Oh, I need to build it. Okay, now let's fetch. Okay. So let's do registration equals, no, it's registration comma version equals this. Okay, so we have version equals 0. That's because the last message's position was 0. So its version is 0. Now let's truncate this table. So we have 0 messages here. And let's do this again. Oh, I know what's going on. So the store will cache all your results. So we need to go out here and reload so that there's no cache anymore. So let's build this. Let's get this command, and let's get a handler as well. And then let us retrieve the version. Here we see version is equal to a symbol called no stream. And what this no stream translates to is -1. Okay, so because there are no events in registration dash the UUID that we have, it's the version is -1, not 0. And if we handle a register command, we will suddenly have a message here, and the last position will be 0. Therefore, our version now jumps up to 0, not no stream. Okay. So now that we have a version, like I said before, we pass that into expected version in the write method. And what this will do is check to see that the expected version, or the last message of the stream, their version equals to this version. If it doesn't, then it throws an exception and won't write to the database. Okay. And that is this handler. Now let me go ahead and write some tests. So let's do some boilerplate. And let's write some more. Let's do some more tests. We want to do the part where we ignore something based. This is our idempotent check. This test will be our idempotent check. And then we'll copy this again, and we'll do a expected version or concurrent. Oopsie. Well, let me just copy this and paste. Cool. And then so let's tackle this test first. Let's build a handler. Now remember what we said. When we use build, we're actuating all of our dependencies. So that means we're actuating the store, we're actuating the message, the Postgres message write object, and so on and so forth. And we don't really want to do that for tests all the time. We don't want to hit the database all the time for our tests. So let's use new. Okay. And let's get a process time. And what we're going to do with that is, this clock dependency right here. We're going to set the time. A lot of people use timecop, but we are just going to set the clock on our own. And that shows, and that with that we have a lot more control over our data and our tests. So we have commands, register, example, and similar with this projection, we just want to copy this, paste. Okay. And then we'll say effective time equals register to time or fail. And then we'll handle it. And we'll get the writer. The writer is right here. That's the dependency and because it's not actuating any actual I/O, so it's not actually writing the database, but it is storing what's passed into it. So whatever is passed into this here, like if this line is executed, we know we have telemetry data on it. So we've got this test, and we want to make sure that we only wrote one message, and that message was a registered event. And then we also want to make sure that it was written to the correct stream. And we have all these different fixtures and stuff to test this with, or all these predicates to test this with. This is all part of the Eventide toolkit. So we can say, hey, was that stream name equal to registration ID? And we got registration ID right there. And let's assert that that is true. Then we want to make sure that all the attributes were copied over correctly. So we've got registration ID, and we want to assert and here, let's go ahead and copy, paste. So this is for registration ID. We want user ID, email address, time, and process time. Here we want email address, time, right? Actually, it's called effective time in our scope. And here we want process time. But of course, we can't actually do that. We need to I believe because the time here is an actual time object, we need to actually parse it into the string format that we're using, and then copy this and paste that. Okay. And let's go ahead and exit out of the console and test. What is failing? Then handle commands, line 33, undefined local variable stream. Okay. Line 33. Yeah, okay. Yeah, that's going to fail. All right, all the tests pass. Let's move to the idempotency test. So we want to create, well, actually, let's, no. So we're doing much the same boilerplate. We want to instantiate our handler. We want a register message. But we also want a a registration that has already been registered, and we have that here. Okay, so we can go and say controls registration, and then we want to add this into our handlers store. And then we want to handle the register command. And let's grab the writer. And we can see, whoops. Much the same as we did in the previous test. We check to see if any, this predicate checks to see, hey, was there a message that, where's a message written to this writer where the event was of the type registered? And then we test by saying, no, there was no event written. Let's test again, and those tests passed. Excellent. Now let's go to the concurrency test, or the expected version test. Here, we're going to have to add some stuff, some controls. Registration component, controls, version. We're adding a version control, and the version control is just, it's fairly simple. Actually, I'll just copy in this, and I'll paste this. It's just an integer. Okay. I think that's all we need. So we do the same boilerplate. But instead of using a registered registration, we use a new one. And then we get our version. And then when we pass it into, this time when we pass it into the store, we pass in, now remember, this is an empty registration, and we're setting it into this registration ID from the command, and then we're saying, hey, that version is really this version, version 1. And this is a way to set up this test. And then we'll handle the command. And let me just copy this stuff. Writer. Right. Okay. So we know that, okay, so we know that the last version is 1. So what we do is now we test this is the stream name, but we don't need the stream name. We want the expected version. And we want the expected version to equal this version, the one we just passed into the store. And then we want to assert that that expected version was written into the stream. And that's how you do that test. And then there you go. All right. Next, what we want to do is run this thing. So in our project skeleton, I added a start script, which basically initiates this component. And the reason it's in the project skeleton is because basically most components I run basically use this syntax, and I don't want to bother typing it in all the time. So we'll have a start class here, and we'll have a start here. Oh, but before that, we're going to want to create a consumer. So let's just do that first. And so what this does is the consumer is what goes out and actually pulls the message store, grabs all the messages related to a single category, and passes them into the handler. So let's go ahead and code it. And it's pretty straightforward here. Namespacing. And then we want to include our Eventide library. And then we want to define, hey, use this handler with this handler macro. And that's the consumer. Now that we have that consumer, we can go ahead and build our start class. And this is pretty simple. So we have our build factory, and all it's going to do is just instantiate a new class of start and then return it. And then we need to define a call method. And what this will do is take any consumers we have and just start them. Now remember, we're not starting this on the registration stream. Okay, this is the stream that is read. Okay, and we want to write to the registration category. Instead, we want to read messages from the command stream, which is registration:command. And then I believe we can actually let's use the I don't want to use the start script directly because we won't be able to see any logs. Instead, I'll use this interactive script that we have because these have certain log tags that we'll be able to see. So we'll run interactive start uninitialized consumers Postgres. Well, let's go back to our consumer. There's a typo. There was a typo. Okay. So you can see that our registration with component was started. It's reading from this category, the registration command stream, the registration command category. And it's got this handler that it's reading only one message, register. And as we add handle blocks for different messages, it'll show that here. And actually, before we test this out, I want to write a helper script to actually, write messages to. Actually, let me truncate this table. Make sure it's empty. Okay. And then, as I was saying before, I want to write a helper script. A helper script here in order to so that I don't have to like instantiate class objects all the time. I just want one single script to write a command to the message store. Okay, so we'll do this, controls, call it write register. Okay, and then because I don't want to like, I don't know, do a bunch of typing, let's go here, write register, and we want to call this method, not have an example. And then we want to pass in ID. We also want to pass in user ID and email address. But we don't want to like, sometimes we don't actually want to, we don't want to pass in these attributes. So we'll have defaults. And we already have classes for that. We already have controls for that, sorry. And we'll use those as our defaults. Okay, and then we'll create a command by passing those in. Now, of course, this isn't actually this doesn't actually take any arguments, so we have to actually do that. And we want to pretty much copy this, right? And pretty much copy this. And then use those instead. Yeah, that should work. And then we'll go down here and write a script, a Ruby script. We're going to require the interactive initialization file. We're going to define registration as, say, ABC, user ID as 123, email address as jane@example.com, and then we'll write it using the method we just created. Okay. So let's clear this out, and we can exit out of this. Now let's go ahead and, oh wait, I'm in the wrong library. Okay. Let's go and, right, so our process is running. Let's write a register command. Huh, that didn't work. Oh, I know what happened. Let's see. If we go here, it didn't actually, I mean, I retrieved a command, but it didn't actually do anything with it. So we'll get a command stream name. We'll use the same helper method to create a command, to generate a command stream name from the ID with registration as the category. And then we'll write this command to that stream name. Command stream name, write, yeah. Okay. Still running. Okay, so we see that we wrote a message. We wrote register to this stream name, command registration command -abc. And let's see. Yeah, our process did did get that register command, and it's handling it. And the way it's handling it is by writing a registered event to this stream name, registration -abc, with the expected version of no stream. And let's see what happens when we try to write a second message. We see that it handled the message, but we're seeing this log message that we wrote before. We see that the command was ignored. And the registration ID was ABC, and the user ID is 123. And now, okay, so duplicate messages, two messages of the same data, is one way for item potency for us to have to make sure that our messages is one way for item potency to be checked. But another way is say we're doing routine maintenance on our server and the process closes, right? Now, some of those processes will, once you restart the process, some of those messages will be rerun or reprocessed, and we have and our item potency check will make sure, hey, we reprocessed this message already. Let's not process it again. And so you can see both instances we have a command ignored log here. So that means we know that both of those messages were ignored the second time they were processed. All right. And that is the consumer. Okay, so let's take the time to discuss what we did with registration, with our registration component. Okay. So we built a registration entity with these attributes and this predicate method. And this predicate method is used by our handler in order to determine whether to write a registered event when it's handling a register command. So when it's handling a register command, it's using this entity right here in this predicate method in order to determine, am I already registered? If I'm already registered, then don't do anything. But if I'm not already registered, then go ahead and write an event. And it does this with this projection, which applies events from its stream to this entity. Okay. Now the problem with this component, and while it is complete, it's not going to do what we really want. Because if we remember, our payload looks something like this: is email rejected? Is email registered? So yeah, we know when a registration is registered, but we have no idea whether an email is already being used by another user, whether it's already in use. And that's because this component is not authoritative over that data. We need to have a second or another component that actually does that. So what we're going to do is we're going to go ahead and make a user email address component. And we're going to initialize the Git repository, and we'll add the project folder to our editor. Move it up here. And I'll go ahead and set up the project skeleton. Okay. So we have a project skeleton with a user email address component. Now, right now, if we look at the settings, we're using the registration component because I just copied and pasted this file over from the other repository. But what we want to do is use a different, unique role or username. So we need to go back to our database here and add a new role. All right, so let's go ahead and do that. Do I have? Oh no, I gotta do it. Okay, so we go into database registration service, add a roles user email address component, and we'll add a message here. Role for user email address component. And it creates a couple of bare bones scripts for us. We get out of this. Let's see. I think we can just copy and paste this. I mean, it's pretty much the same. We're just trying to keep things like keep the roles separate, because what if like we want to be able to differentiate different roles for different components. All right, so we're basically doing the same thing. We're creating a role, which is we can log in with. We're granting the message store reader role to that component, and we're granting the message store writer role to that component, so it can read messages and write messages. And we're changing the search path so that we can run queries within the message store schema without having to actually type in the schema all the time. All right. And here we're just going to drop role user email address component. I think that's the same, right? Yeah. All right. And then we can copy that, paste user email address component, save. Okay. And then we will, oops, I shouldn't have closed that. We will deploy those migrations. That role was deployed. And let's go ahead and we can get out of here. And also, let's see, the message store settings. We are using this new role, and we can go ahead and test that by checking the database connection. And yeah, the database connection works. Let's see. Let's close all the tabs. All right. So we have our registration component. Now we have a separate component that's going to keep track of whether an email address is unique or it's being reserved by another user. Okay. So rather than, let's a good place to start is let's determine the relationship between the registration component and the user email address component. Okay, so we're writing register commands to the registration component here, right? What we want to use is some sort of communication method between these two components so that the user email address component knows, hey, there's a new registration here. Let me go and check and see if this email address that the registration component has is actually reserved or not. And if it's not, then we need to return a message we need to write a message that says, hey, that's not. I mean, it's already in use. So I think a good place to start is with the entity. Okay. So here, the entity is the user email address. And let's see. We need to add a class called user email. Right. Okay. And like before, I'm really not going to be using I'm not going to do tests first right now because I really want to showcase the concepts rather than write tests first. And you wouldn't necessarily know why I'm writing a test for a certain reason or whatnot. I think it's easier to learn this way. So we have our user email address, and since it's a entity, we include this library, and we define a couple of attributes. We'll have email address, we'll have user ID, and we'll have something called claimed time. Whoops, that's a time. And similar to the other entity on registration, the registration entity, it will have something like this, where this predicate method will determine, hey, was this already claimed or not? Okay. Now, something else we also need is we need to encode email address. And this is something you need to keep in mind with user-derived inputs that don't like conform to something like an ID, like a UUID or something. When a user inputs an email address, there can be all kinds of security shenanigans that are going on that users or malicious users can do to like wreak havoc in your systems. So what I like to do is encode my email addresses, typically by downcasing them and then like doing some sort of SHA-256 digest of that, and I'll show that later. But right now, just know that this is our encoded email address, and this will serve in the same function as ID on registration. Okay, we're going to use this to fetch entities from our store. Okay, let's go ahead and write some tests. And this one's pretty similar to this test up here. So I'm just gonna cheat and copy that, paste. Okay, user has have claimed time. Okay, and you can see that when we run the test, it fails because we don't have any controls set up. So let's go ahead and do a little bit more copy pasting. All right, we're gonna need this, we're gonna need this, and we're gonna need this, and maybe this. Actually, no, we just need these for now. Paste. And since I'm lazy, I just want to copy and paste. Copy, and paste. I don't have this. I don't have this. All right. Okay. So we change this to user email address. And let's change this to user email address component. And change this to user email address component. And then user email address component. User email address. And we don't need this. Well, actually. Oopsie. Okay, so here we are doing things a little bit differently. Yeah, we need to build a new address. We're not using ID, we're using encoded email address. So we need to have an encoded email address and return that. So here, instead of that, we'll have SHA to hex digest. Email address dot down case. Okay. New user component. Right. And then claimed. Right. Okay. And then we go back to our test here. If it's claimed, then we got that. Otherwise, it's not claimed. Actually, I probably want to just do. Here we go. Yeah, that makes more sense to me. Let's run that test. Okay. Does not have claimed time. Must have done a typo on here. Or maybe on the entity? Yes. Uninitialized constant. Oh. Okay, well, I think, because I'm going to need this later on, so I don't want it to just be in the controls, so I'll require digest here. And this is a Ruby standard library, I believe. But that means I'm also going to need to load it here. And I'll show you why. I'll let you know why I do this, but right now, you'll find out later. Cool. Okay. So we're not done with the predicate. We're not done with the entity here. Okay, so there's a little something different about this component than there is about this, the registration component. And that is the registration component, its lifetime is finite. Its lifetime ends when the registration is registered, and then you don't need to worry about it anymore. So it has a very few and finite number of messages. Whereas or events, I should say, has a finite number of events in its stream. Whereas the user email address component, I mean, this could be potentially the lifetime of the application, the lifetime of the email address. And therefore, it needs to be able to accept or handle any number of events and commands like if different users are registering and we want to like see if this email address is claimed already or reserved already, this data structure doesn't handle that. Now, Eventide has a way to do that here. And we just want to make sure this is where the mechanical logic kind of intersects with the applicative logic. We're going to check and see if a message was processed already. Okay. So if you remember, here, let me just. So we have that, but we also need to add an attribute. Okay. Now, if you remember, let me open up PSQL with this user. If you remember, each message has a global position. And because this is a Postgres serial type, it's unique and it's usually auto-incrementing. What we can do is we can record this global position into the stream, so inside here, and then use the projection to compare whether messages of this global position have already been processed. And if they have been, then we can safely ignore them. Now, why would we do this instead of like, say, I don't know, doing something like this where we have like IDs and it's an array? Well, this array can be infinitely large, and we just don't have. There's not enough memory in the world to be able to like to store all this into some sort of memory data structure, in-memory data structure. So we need to do it this way by using the natural mechanics of the message store. Here it's the Postgres serial, and use that to our advantage. So we're storing the sequence, or the global position if you prefer. And then we're going to use this predicate method, processed, to make sure for whatever message sequence that we pass in, is it already been processed? Now, if there's no sequence stored in our entity, then we know we haven't processed any messages, so we just return false. But if the stored sequence here is greater than the message sequence that we're passing in, then we know this entity has already processed. Like, say this stored sequence is 4 and this message sequence is 1, 4 is greater than or equal to 1, then we know, hey, this entity has already processed messages up to 4, so we know we've already processed this message. We need to ignore this. All right, so we need to write another test. Okay, let's copy this. Okay. All right. So we have a couple of contexts here. Has not yet processed any messages. And we have some contexts has processed messages. Okay, and there's 2 separate cases here where user email addresses sequence is lower than the sequence. let's say message sequence here, and also user email addresses sequence is nil. Here we have two contexts as well, or two different cases. User email addresses sequence is greater than the message sequence. And here we have context user email addresses sequence is equal to the message sequence. Okay, so before we move forward, we need to have a way to input sequence. So what we're going to do is, well, actually, so where was I? Oh, so we need to have a way to set sequence here, right? And so what we're going to do, we're going to set the user.sequence equals that sequence unless sequence.nil. So if there's no sequence that's passed in, then just don't even set it. It'll be nil in that case. And then down here, we're going to have a different module. We're going to define the control later, but right now we're just going to declare it, and then we're going to say, hey, just give me a user email address with a sequence of sequence. Okay. And then let's go to controls. We're going to have, actually, we're going to also have position here. So position and sequence are interchangeable, but they have different cases where one you would refer to position and one you'd refer to sequence, and you don't want to, sometimes you just don't want to mix those up. And if you look, this seems very familiar and similar to version, you know. Yeah. And then here we'll just do the same thing, but sequence, to make it more clear that sequence is derived from position, we'll just say, hey, sequence equals position. Cool. And so here we've defined the sequence here. And now let's go back to our test. Okay. We'll use sequence here. Oh, I actually didn't need to do that, but whatever. This is actually going to be used in a different example. But actually, I'll delete this. All right. So we have our sequence here. We've defined that there. And then we're going to get a user email address entity, user email address dot example, where the sequence is lower than the message sequence. All right. And oops. So we're going to say, hey, check the predicate. Is this processed with this sequence? Actually, I'm not sure if this adds any clarity. Okay. And then we'll test that by refuting. We're pretty sure that that's not processed. And actually, this is also the same test. but the sequence is nil. Or the entity sequence is nil, right? And then here we're going to paste again. Here it's greater, so we want to do a +1 here. And then we want to test by saying, hey, that is processed. So we're asserting it, not refuting it. And then here, let me just copy and paste this. Here we need to say this is the sequence is equal, the entity sequence is equal to the sequence. So we don't need that. So let's run that test. Yeesh. Undefined local variable user email address. Where? Under, oh, in the controls. Alrighty, let's go look there. Whoopsie. Huh. Okay. Okay. Looks like that test passed. All right. So we've got, let me go ahead and close all this. So we've got our entity. Next is our projection. Let's see. Just doing the same thing I did with the registration components projection. And here, let's go create some events first. Actually, I should really just be doing the messages first, not the projection. I don't know why I switched them up. So here we have messages, events. We need to have a claimed event, and we need to have a claim rejected event. Okay, so let's go back to our entity. Here, if say this user email address hasn't been claimed yet, so that means this claimed time is nil. All right, that means when we receive a claim on this email address, then this is nil. So we can return. That means we know we need to write a claimed event. Now, so that user has claimed that email address. But a second claim comes along. Now the entity says, hey, this has already been claimed. We can't claim it anymore. We need to write a claim rejected event. And that's what this is. So let's go ahead and do that. And we're going to include this and add some attributes. Oops. User ID, time. And then one last attribute. This is looking a little bit familiar. I mean, there are some different ones like claim ID and encoded email address, but we had user ID and registration. We had time and process time, but we also need to record sequence. We need to record the global position that the previous message came from. Okay, that's sequence. And with this sequence, we're going to populate the entity sequence. Okay. And really, claim rejected is not that much different. We're going to have here, it's going to have a claim ID like this one because it originates from the same claim. And it's going to have encoded email address. It's going to have user ID. Should I add email address? Yeah, go ahead, add that. And here too. But it's not going to have process time because I want to differentiate between a claim. So the claim action came from the claim command, which we don't have yet. But the process time is the difference is different from the effective time of the claim. But when we reject the message, we're creating a whole new event. So that's why I like to use this. You just use the effective time. This is rejection of the original claim. You'll see. You'll see, but just know that rejection of the claim is different from the claimed event. All right, but it will still also have a sequence. All right, so let me add that here to our loader file. Cool. So we have our messages here, and we're going to apply claimed, and we're also going to apply claim rejected. All right, we'll do this one first. Really, we want to take all of these, right? All of these attributes, and we want to let's go ahead and do this. So we want to say, hey, user email address dot. All right, this isn't working. I know this better in Mac OS, but all right. So we get basically we're saying, hey, claimed, encoded. Set that, and then set claimed email address, and set claimed user ID, and claim time equals clock.parse claimed.time. And for our rejected event, we just want to set the sequence. Oh, whoops, I even forgot to set that here. Equals to claim.sequence and claim rejected.sequence. Okay. We will need to write a couple of controls here. I think we're going to need We'll just copy that from this repository and paste it over here. Rename it to claimed. User email address component. Claimed. Claimed. All right. Encoded email address. Right. We're going to need user email address. Encoded email address. Copy. Paste. And user ID. We're going to need a user ID. So more copy paste. Copy. Paste. Okay, so we've got the user ID. What else? We also will need, because we have a claimed ID. Claim ID. And we'll just use the random ID. Let's see. So we've got our encoded email address, user ID, time, process time. Oh, of course. We're going to need sequence. And that's where our sequence.example comes in right here. Yeah. Okay. And this is not that much different. So we'll just copy and paste and rename this to claim rejected. Claim rejected. Ooh, typo here. All right, we don't have process time. We do have claim rejected, claim ID, encoded email address, user ID, time, sequence, claim rejected. Okay. Yeah, okay. So now let's write our projection. Let's go ahead and copy pasta here. Select all. Copy. This is really what a lot of event sourcing is like. Basically pasting stuff. Okay. 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 Encoded email address. I'll go ahead and copy this and move this. Okay. Encoded email address is set. All right. Email address is set. User ID is set. Claimed time is converted and copied. I'm going to need another one of these to make sure sequence is set. Sequence. Let's move this here. Just okay. Let's go ahead and run this. Ooh, uninitialized constant controls registration. Did I forget to? Yeah. Okay, uninitialized constant. Okay, yeah. I forgot to load this up on controls. Require user email address component controls events claimed. And then this will be claim rejected. And what do you know? I forgot this as well. Let's see. One is not a kind of string. Did I set the incorrect? Did I set the incorrect attribute? Let's see. User email address is integer. Yeah. Probably want that to be an integer. Want this to be an integer. Of course. Undefined method registration ID in yeah. Right. Okay. Encoded email address. Encoded email address. Email address, user ID. Let's see. We also want reserved. Sorry, claimed time. ISO 8601 equals claim.time or fail. Sequence equals claim.sequence or fail. Time.parse. Claimed time. Yeah. I think that works. Ooh, uninitialized constant. Ooh, did I? Forgetting to load a lot of things. Yeah. Actually. Oops. All right, cool. So that is one test. But we need the one for claim rejected. Okay, so here, probably going to want to do that. I don't think this will work with an empty entity. All right. And then, all right. And then we don't really need this. But we do need, okay. So we want this example. We really only care about sequence. So add this, and we can delete this all the way down here. Yep, that test passed it as well. All right, so we've got our projection. We're well on our way. Close everything to the right. Let's see. The next thing we would probably do is the handler. But before we do that, let's add the message. And this is pretty similar. Copy. This is pretty similar to the claimed event. Claim. The only thing we don't have, obviously, is process time. And we also don't have sequence, because that comes from the global position of the command. Right. Okay. Let's add this here. Right. Okay. And then let's also add this. And let's go to the control. We'll just copy pasta this. Paste. Paste. Oopsie. Copy. Paste. Rename to claim. 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 All right, so commands claim, claim ID, yep, encoded user ID, process. Now, there is something different here. All right. We don't have process time, right? But we also don't have sequence yet. We have to set the metadata.global position. That's why we had a separate position. Even though they're the same, their names are different, and names are important. So we have our claim, we have our encoded email address, we have our email address, user ID, time, and we set the position. This position will then be used to populate the sequence of the event. All right, so we've got our message, and now we need handlers. Now, there's going to be something a little weird about these handlers, okay? Because remember, we have we could have potentially an infinite number of claims coming in. So we need to be able to have our handlers be idempotent. I'll just set this up first, and then I'll explain. This is looking very familiar. Yeah, I think I'm just gonna copy and paste some of this stuff. Let's copy that, Paste that. Oh, don't forget our store. We need that. And I will just copy. And obviously this is going to use their user email address category. This is going to use the user email address entity. It's going to the projection. They're the same name, even though they're different classes. And we're going to use this class for the reader. Now, we need to set this. Okay. Oh, and we also need to set this. Okay. Now, let's set the category to user email address. And now let's also write our first handle block. Now we could do the same things here. Let me just copy paste from the previous handler here. It's different enough that I probably want to do things differently. All right, we'll do things differently. All right, so remember how we're using encoded email address as our fetch ID. Okay, so we get that. We get the user email address and version from the store, including the version. If the user email address is processed, oh, we need the sequence. So we need to get sequence equals claim dot metadata dot global position. Okay, that's our sequence. This is the message sequence. So then we're going to go into the processed predicate right here. See, you pass in message sequence, and then we compare this message sequence to the entities sequence. If it's already processed, then we just return. And we just ignore that message. We ignore the command. Let me write a log. We log it. Command ignored. User email address. User email address dot email address. User email address sequence. User email address dot sequence. Claim sequence. This is just for my own edification when I'm looking at logs. And then we do things as before. We record the time. We get the stream name from this helper method with the encoded email address. And then we write a claimed message by following the claim command. We set the processed time equals the time. We set the claimed sequence equal to sequence. And then we write the claimed message. Right? This is looking very familiar. Now, of course, we're going to need to do something a little different because there are conditions. So if the user email address was already claimed, Remember, we're supposed to be able to know. We're supposed to try. This is checking to see, is this user email address already claimed? If it's not claimed, then claim it. Otherwise, reject that claim, right? So we want to return here, but we want to write a separate event. And we're pretty much copying whatever is here down below. You know, we follow the claim. We record the time. We record the sequence. And we write the claim rejected event to the stream name with this expected version. So there's 2 branches here based on this conditional. Okay, and this will all be this is all idempotent because we're not we're using optimistic locking in both cases. So that protects against concurrency, but with regard to idempotency, we're checking to see, hey, is this message processed already based on the sequence? Now, there is a problem with this. Let me just show you what the problem is. Let's see. I'm going to do. I'm going to write a script similar to this write register script. I'm going to write something completely very similar. So we'll do write claim.rb. Actually, yeah. Active init. So let's say claim ID equals, I don't know. Let's do that. Okay. And then user ID equals 1, 2, 3. And then we write a claim and we say, hey, claim ID is equal to that, email address is equal to that, and user ID is equal to that. Okay. Now we also have to go here and no, we have to go to the controls. Right. Okay. Write claim. Okay. And we want to write the claim here. User email address component, module controls, module write, module claim. All right, def call email address and user ID. Okay. So ID will be equal to ID. Email address will default to user email address.email address, and user ID will default to user.id. Right, we know all this. Then we want to get the encoded email address, which will be digest SHA-256.hex digest email address downcase. And I know this is replicated here, right? I don't care. You can copy, despite what you may think, you may copy code elsewhere. It's not a big deal. Dry or don't repeat yourself doesn't apply in every single case. So here we're going to pass it this. We're going to pass this in. Email address, user ID. Okay. Then we need the command stream name. Ooh, that shouldn't have happened. Did I misdo that? Yes, I did. Okay, there we go. This command stream name, encoded email address, user email address. And we're using camel case because message DB, when they encode on JSON, they encode in camel case instead of snake case. All right. And of course, we're going to have to change this. So let's just go ahead and copy this. Let's see. And of course, we're going to need this. Okay. And then all right. Okay, I was trying to demonstrate something. I've got this working. Let me see if it works. Ruby test interactive write claim. Undefined metadata in claim commands. But no. All right. So that is correctly set. Let's see. We want to say PSQL host 0.0.0.0. Okay. Actually, let me truncate these messages so I can. Actually, did I need to write this? All right. I think you can see the problem. I don't have a consumer or a start object, so I need to. I think I'm just going to write. I'm just going to use an IRB console requiring test. Okay, let me try that again. Awesome. Okay, so we have a claim where controls commands dot claim dot example, right? And we have a handler dot build. Okay. So let's truncate here. And then let's handle the claim. And at first, as we expect. Okay. Ah. Yeah. What we expect to happen happens first. A claimed event gets written to the message store. Okay. But let's say we handle the exact same claim again. What we expect to happen is that this duplicate message doesn't get handled a second time. It does not get processed a second time. But what do we find? Let's see. All right. How am I supposed to demonstrate this? Let me think about this. I know this is correct. My thinking is correct. I just don't know. I just don't remember the conditions to. I remember. Okay. So the reason this is having so much trouble is that the claim dot message dot global position. Oh, sorry. Metadata is 1, and that's not simulating the conditions that we're expecting this in. So if you think about it, let's say you have 2 duplicate messages accidentally written to the message store. They wouldn't be in the same global position, and actually the metadata global position would be quite different. It might be equal to 2 this time. So what happens if this handler handles this message? Now we have 2 messages. And because the first event was claimed, that means the entity is now claimed. We're now writing a claim rejected event. This is not what we wanted. Okay, just because we accidentally write the same claim, and this is the same claim because the claim ID is the same, we don't want to process this message a second time. Now, how are we going to do that? What we have to do is we can't use this in the way that we have it right here. Okay, we actually need a separate handler to handle this. Okay, to handle so what we're going to do is create it. We'll copy this and paste it somewhere else, but we're not going to use it right now. Okay, so that's sitting there, and then we're going to delete this and start over. Okay, now what we need is a separate dependency that we haven't yet installed. So we're going to need to add that dependency here. And that's the try library from the Eventide toolkit. And what this will do is, well, I'll show you. So we've got our try library. And then here, we don't actually need this clock or this store. Okay. So what we're going to do here is we're going to use the message store's inherent capabilities, okay? But what we're going to do is we're going to take a separate transaction stream name. So there's going to be two streams. Well, really three. There's going to be the user email address command stream. There's going to be the user email address stream. And what we're going to use here is a user email address transaction stream or uniqueness stream. And what we're going to do with this is we're going to create a stream name with the claim ID. Okay. And the user email address transaction category. Let's see. And we're going to use a cardinal ID. You don't need to know too much about this, but I can show you what this will do. So let's say you have a messaging stream name dot stream name. Say you have an ID of 123, and you have a category of user of test, and then you want to do a cardinal ID of ABC. That basically, what that will do is add this cardinal ID above before this will. This is the ID, and what it does is, now we have a stream name of test and ID, and now the cardinal ID is prepended with a plus sign before the ID here. And this is just so that in the future, when you're running consumer groups and stuff like that, when you want to do some horizontal scaling, you don't accidentally shoot yourself in the foot. So it's not really something you need to worry about now, but it is something I add here just because it makes sense. All right, so we've got our transaction stream name. Now we just copy the claim. All right, and then we try to write, and we use the initial method here. So the initial method basically says, try to write this command, this message to this transaction stream name, and then it's the same as if you did this with expected version -1. Okay, but it's just a handy convenience method. So it's basically saying, I expect this to be the first message of this transaction stream. If it's not, throw an error. And then when this error, we're going to catch that error. If it does throw an error, we're going to catch the error and suppress it. So this is the error that it will throw. If there's already a message in this stream, then we know don't try to do anything with it. So in this way, we can use the claim ID as a reservation. And actually, this is the reservation pattern. So let's go ahead and exit. And we'll do this again. So we've got our claim. Oh, I need to install gems again because we did add a dependency. Right, okay, now that's working. And we want to have a handler. Actually, let me truncate these messages. All right, and now now when we do handler.claim, what we expect to see is a claim, another claim on this stream. It's not on the user email address command stream. It's on the user email address transaction stream. And it's got an encoded email plus the UUID of the claim ID. see this ID matches the claim ID right here. Now that we have this, we know we can create a handler off of this stream name. And if we try to do this again, it won't work. In fact, it probably threw an error. Okay, so we've got this, and now we can create a separate handler called transactions, and it's very similar. Okay, and basically with whatever we use there, we can use here. And yeah, this all looks good to me. Okay. So here's what we've done. We know with this handler that any claim message with a unique claim ID will only be written to this stream once. Okay? And we won't get, even if they write this claim message twice, like with the same claim ID, it doesn't matter. It will only be written once. And then this transaction handler will go read from this transaction stream name, and then do the normal, concurrency protection and idempotent protection. It will be able to know, hey, was this message processed? And then if it was processed, then go forward and check to see if the user email address was claimed. If it wasn't claimed, then reject that claim. If it was claimed, then reject that claim. And if it wasn't claimed, then go ahead and claim it. Okay, that was a lot. All right. What I'm going to do next is write some tests. I'm not going to bother handle commands, handle transactions. Okay, the difference between this, obviously, if you have this code is a lot different from here. So we're going to have different tests. And I don't know if I'm going to actually go a lot into it. But you can watch me as I type. So the difference between this test and our other handler test is that we're actually actuating an operation. We're operationalizing an actual handler with Postgres dependencies activated. Now, why do we need to do that? Because we need to make sure that we can only make sure that this reservation, that this was written actually with this right here with Postgres active. We can't do it with mock objects or substitutes. So that's why. So we're expecting a transaction stream name of user email address transaction with claim.encoded email address plus claim ID. And then we're going to read from the message store Postgres we're going to read the initial message here. And then we need to parse this message. With this class. And then we're going to test, hey, this claim command was written to and then we need to test that all these attributes were copied over. And I'm going to go ahead and copy, paste for encoded email address, paste for email address, user ID, and time. That is encoded email address. This is email address. User ID. And time. All right, let me see if this works. All right, I cannot load file, obviously, because I didn't load it. Cannot load such file. Did I? Oh, I didn't put this in the correct folder. All right, undefined variable method transaction for, let's see, undefined local variable transaction on line 5. Uninitialized messaging message. Oh, too many letters. Okay, that passed. And if you look, since we can see that it's actually writing messages to the message store. See, right here. And let me just show that for real. Truncate. We don't have any. And then it's going to write some messages to the message store. See, right here. And here it's just testing. Hey, when this handler receives a claim command, does it write this message? Does it write a claim command to this transaction stream? And are these attributes copied over? That's all it's doing. All right. Now let's do, we're probably, all right. Let's select all because we're probably going to need a lot of this same code here, the not reserved test. So paste. Not reserved. So we're going to need a claim ID. We're going to need claim. We're not going to handle it just yet. We're going to need a transaction stream. And we want to write. We want to have a case where this message is already written to this transaction stream. Okay. So we write that, and then we go ahead and handle this message. Okay, and then we grab this data. And then we say, hey, this claim command is not written to transaction stream. Data.nil. We assert that event data is nil. Okay, assertion failed. What failed? So let's see. Claim ID. Write this to this transaction, then handle this command. Get. Oh, I know. This is what we want because we already wrote a message here. This claim command is in event 0 is in position 1. I mean in position 0. We don't want to read from position 0. We want to read from position 1 to see if there are actually any messages that were added after we wrote this message. So, okay. I see what I did wrong. And of course, the test passed. Awesome. I'm going to go ahead and commit a lot of this. Actually, I'm not done. I need to write the transaction tests. These are going to look very familiar. Okay. And I will use a lot of these. I think I'm going to need, let's go here. We'll use this first. Select all, copy. Ignored. And then okay, we've got a claim. And now we need to this is the entity, of course. And then we already have this entity is already claimed. No, sorry. This is not that. This is a sequence example. Okay. Right, so handler is transactions, claim example you, okay. And then let's just add a test here just to make sure that the user email address dot okay. Actually, right, okay. We need to write that control. So we need to go here. And then we just say sequence equals controls, sequence example, and then user email address dot example with this sequence. All right. So we need to assert that. We add this to our store on the handler, user email address, and then we claim that. Handle the claim, then we get the writer, and we and then this should be nil. this test is correct. Let's do expected version. Okay. I'm just gonna, let's copy this. Oops. Select all, copy, paste. Expected version. Okay, so we've got a handler, we've got our claim, and we've got our entity. And now we need a version. Do we have version? We do not have version. All right, let's add that. Let's just grab it from here. Copy. Excellent. Now we go ahead and we have to load that on our controls file. Okay. Now we have our version. We don't really need this, but we do need to add this here. But we also need to specify that we're setting this version here. Claim encoded email address, user email address version, handle the claim, write claimed equals. This all looks good, but this test needs to be different. Test is entity version. Written to stream. Write that test. Ooh. Assertion failed. Let's see what this is. Expected version. Block 29. Line 29. Okay, so it did not write with the expected version. Am I using expected version? Yeah, I am. I'm getting the version. Okay. So I might have to write. Let me just run this test by itself. Handle test automated handle transactions claim. Okay. What is going on here? Debugging this can be a pain. Yeah, I've got the version. I've got the sequence. Boom, boom. And okay. Oh, I know. I think I know what I did wrong. All right. I copied and pasted here, and I'm using the sequence example when I really want to use new. I'm such a doofus. All right, let's see what happens. Yep, that worked. Of course. Because since it was using the sequence example, well, actually, I don't know. And okay. Well, okay, I am curious. Okay. So if I go to this entity here, the sequence example uses the base example, which is up here, which will have encoded email address, and we'll have a sequence. And that will fail, of course, yeah. So sequence example is using claim. Oh, I see. It's because this expected version test, when it runs this message, since it has a sequence, that means it'll say, hey, this has already been processed. In fact, let me try, hey, actually, let me do foobar. Actually, yep, it ignored that message because of the sequence example. That's why. I understand now. See, that's why you got to be careful with these. And yeah. All right. Now we want to write this test. I will copy a little bit here. Copy. Paste. Claimed. Actually, a lot of this is the same. Well, actually, I will need a process time. And I'm gonna set the clock to that process time. And I need a claim command. And I'm just making sure all this stuff is fine. Email address equals claim.email address. User ID equals claim. Let's see. Dot time of fail. Global position equals. There we go. And then run that. I'm just gonna copy and paste from registration at this point. Nah, fine. I'll just. Which one's less tedious? Let me see if these tests are... All right, so far I'm writing these correctly. And then I'll just copy paste these. Paste. Time, process time, and all right. This will be encoded email address. This will be user ID. Actually, no. Email address. This one will be user ID. This one will be time. This one will be process time, but we're going to do something a little different here. We have to parse this. Okay, so we pasted that, and then this will be sequence. And of course, this will be global position. And our test is broken. So which one? Local variable name or method time. Of course, I was wrong here. This is effective time. Yep, awesome. And now let's go ahead and select all, copy this, and put this into the rejected test. So this is very similar here, except after this clock has been assigned, we probably want to user email address equals. We want to set the handler's store to a user email address that's already been claimed, and we have that example right here. Okay, and then everything after this is pretty much the same, but this isn't a claimed event, it's a claim rejected event. Okay, and claim rejected, claim rejected, and it's written to the same stream, so we don't need to change that. Claim ID will be the same. Encoded email address will be the same. Email address will be the same. User ID will be the same. Time will be, we'll use processed time. And then sequence will be the same. And of course, we got it done. All right, go here, close all the tabs to the right. All right, let's see this in action. And to do that, we need to create consumers. And we just create the same consumers we have as many handlers we have. So we have a handlers, right. We have a commands consumer and we have a transactions consumer. And then here we paste and we just replace. Okay, so we've got consumers. Now we need the start class. Okay. It'll be fairly much the same. Okay. What we're going to do is we're going to start both consumers. And we're going to start it from the user email address command category. And then the consumers transactions will start from the user email address transaction stream. And there, undefined method new for. All right, let's look at this module here. Oh, it's not supposed to be a module, it's supposed to be a class. I thought it might be something dumb like that. All right. All right. Okay, so we had a lot of messages. Let's run it with an empty message. Okay. Here we can see let's run this here. Here we can see something very similar to the registration component. We're running a component here, and it's got two consumers, each of them running one handler. And these are the handlers and the messages that are being read. Now, let's go ahead and write a claim. Okay, wow, a lot of stuff happened. So as you can see, the first handler copied the claim message over to the user email transaction stream. Okay, and it's got the claim ID of AAA. And then the second handler, the transaction handler, retrieved the entity for this encoded user email address, and then it wrote the message claimed to that to that string. And we can go ahead and see this. Actually, I want it to be auto. Okay. So as you can see, our initial write script wrote a command here to the command stream. Then we copied that message over to the transaction stream. Okay. All this data is the same, except for the metadata. This metadata is written with the Eventide toolkit, so we don't really need to worry about it too much. And then we to the actual entity stream, the user email address dash the encoded email address. We have the time, we have the user ID, we have the claim ID, we have the sequence. This sequence comes from this global position number right here, global position right here. And so this was added, and then also process time was also added. All right. Now, what happens if we write? Let me show the script again. What happens if we write this exact same claim ID to the message store? Okay. So it handled the second claim, but it didn't really do anything with it. Like if we look here, there's still only there's 4 messages here. So this is the additional claim that we wrote. But nothing happened. Okay. We can also change this to be a different claim ID. So it's a completely separate claim. Someone else is trying to claim this. We'll just make it. Well, we can change it. We can do this. Someone else. This is viewed as a different claim because it's a different claim ID. So the component will regard that as a completely separate claim. So let's write that message here. And here we can see that we did much of the same things, that we wrote to the transaction stream here. We wrote this message to the transaction stream, but we also wrote a claim rejected event to the entity stream. And that's because the email address of jane@example.com was previously claimed by another user. All right, and that's that demonstration. Let's truncate those messages. I'm going to change this to be some random. Actually, I'm going to leave it as it is. What we need to do now, this user email address component is mostly complete. We have a component. This user email address component is now authoritative over reservations to email addresses. And now we need to have a way for the registration component to communicate with the user email address component and write messages and pass messages back and forth. And this is where event sourcing really comes into play. All right, so we have our user email address component completed for the most part. And we also have a bare bones registration component that still needs to be modified in order to communicate with our user email address component. But before we do that, we need to allow the messages here to be accessible to the registration component. And the way I like to do that is with a separate gem from the normal component gem, something called the client gem, which will have access to just the messages like commands and events and the controls, but it won't have access to the projection, store, or the entity. And the way that we do that is, if you look here, this was added with the skeleton, with the project skeleton. We add the controls, we add this load file, and we add different, and inside the load file, we add whatever's in there, which was all the messages. And then we add anything that's inside here, this folder called the user email address folder. And what we typically do is we add a client file, and in here we add the Eventide messaging Postgres library. And this is already a dependency on this gem, this client gem. It's already a dependency. And then we add the load file beneath the user email address component. And then we also add something we also try to set the name spacing. So let's go ahead and do that here. And what do I mean by that? Oops. Right here. So we want it to be accessible as a module on registration component. So here we say user email address is a module. And then we want the client to be equal to, we want this to be equal here. So the way the registration component will access this is user email address client. And then any messages here will just be accessible here like this. So we've got our user email address component messages and like this, like so. So if we want to access messages, we just say, hey, messages, events, and claimed. Something like that. Now we want to also have our controls. And we do something very similar. So we'll just require the controls from the component. And then we'll set our name spacing. And this is all pretty much the same, but just for the controls instead of the messages. All right. Okay. And with that, we can add this to our registration component. We'll want it to add it right here inside the gem spec file. And you can see we have a similar one here, which we will be using when inside registration resource. But we haven't gotten to that point yet, so I'll stop jumping ahead. So we want to add this dependency that we just created, user email address client. And since it's not actually on Ruby gems, we need to define it inside the gem file, which I like to do here. And it's just up one address, up one. It's just whatever the path is. And then we can go ahead and reinstall our gems. And as you can see, user email address client was added from this source. So we added the dependency, but we also have to add it to our loader files. So let's go ahead and do that right here. And now all user email addresses, client messages will be accessible to us from the registration component. And likewise, when we're testing, we want to add the controls. So we'll add that here. Okay. So, whoops. If we go ahead and go do this, IRB require we can see user email address, client messages, commands, claim. It's accessible to us. Cool. So let's look at our handler again for a registration component. Right now we just have a command handler, and all it's doing is writing to it's taking a register command and writing a registered event. And this isn't really useful to us because if you think about the business process of registration, we want to actually go ahead and confirm that our user email address is completely unique within our system. And if our registration is already registered, then it doesn't matter if it's unique at this point, because it's already registered and like the business process has already been completed. So what I want to do is I want to be able to say, hey, let's do this whole process where we go here, right? But this is our entity, and we want to actually have a business process where we say, let's initiate the process, and then if the user email address comes back as unique, then we'll go ahead and say the registration was registered. But we can also have a registration be canceled if the user email address came back as not unique, if someone already is using that email address. So let's and likewise, we want to be able to track the messages from our user email address component. Okay. So in that way, we want to be able to say, hey, the user email address component accepted the address, or it rejected it. Okay. Right. So these are different times inside this little business process. And you can see that this entity is starting to become more like a finite state machine with two divergent paths. Like, it all starts with this initiated time. Well, actually, it starts with the register command here. And then with this register command, we go from register command to an initiated event. And then with that initiated event, we go and send messages to the user registration component. Okay, the user registration component does its thing, right? And then it'll come back and tell us, and then it'll come back and send a message saying, or it'll write a message to the message store saying that email address was claimed, or that claim was rejected. And then we'll have this attribute for recording those responses. And then depending on the simple fact that, okay, we have an email that was accepted, then that means you're registered. Or if we have an email that was rejected, and that means you were canceled. So it's kind of a very simplistic finite state machine. All right, so let's write predicate methods for these. Actually, let's go ahead and do this like test first, right? So let me go ahead and copy this. Let's do a bunch of copy paste, right? Okay. All right. So cannot require such file. Oh, I know why. I did something doofus-like. uh, right, okay, that's what I expect to see. So we have an uninitialized constant. So we need to add the initiated event. So we'll just use this, copy, and paste. And add this. So we've got initiated. Now we need to add that as a control. And let's go into our controls, copy this control or registered control already and paste it. And rename it to initiated. All right, so now we have an initialized control, a registration control. Right. So let's go back to our registration control here. And this is what we're talking about. We don't have a initiated control here. So let's add that. And we don't want to go too complicated. Let's just say the base example is initiated. And then we'll add that here. Yeah, okay. Let's see where our tests lies now. Undefined method initiate. So we don't have an initiated predicate. So that's where we add that here. Cool. And let's see. Does not have initiated time. Okay. Let's go look at that registration control again. So, and then let's look at this test. That's not a test. Here's the here's the test. Right. This needs to be : new. Okay, and now we've got this test correct. And we'll do the same thing for all the other predicates. But we might go ahead and just do these all. Okay. Let's see. Copy. Actually, duplicate. Email accepted. Duplicate. Email rejected. duplicate, canceled. Cool. Let's go ahead and start with this one. Okay. Boom, boom, boom. We need to go here. Right. Actually, I'll just do a bunch of copy and paste again. Copy. Paste. Right. Okay. And then email accepted. Email accepted time. Email rejected. Email rejected. Email rejected time. Registered, it looks fine. Canceled. Canceled time. Registered. Let's look at the entity ones. Email rejected, correct. Email accepted, canceled. Everything looks good here. All right, so our entity has been updated. Now we need to update, what I like to do next is I like to update our projection. Okay. So our projection needs a little work here. This one, if we think about it, registered is the last event, or one of the last events. Registered and canceled are one of the last events that will actually be used in this projection. Because initiated will most likely be our first event. So we don't really need user ID. We don't need email address here. So we can get rid of that. And of course, a bunch of stuff fails. I'll go ahead and copy this. But right now we want it to be like this, okay? Register time. We are okay with the ID being set. We are okay, but we don't want the email address to be set because we don't really care. Let's see. So we don't need this. Okay. I'm pretty sure this is okay. No. Oh, it's the initiated. The register test is fine. The initiated test is not fine. Okay, here we need to do a couple modifications. So everything here probably can be now converted over to the initiated event. And same with initiated time. Uninitialized controls events initiate. Oh. Uh, okay. So the reason these tests are failing is that nothing's happening inside the projection. So we need to go to the projection and let's go ahead and just copy this. Copy. Paste. Bring this back here. And then this can be changed to initiated. This event can be changed to initiated. And then this should pass with the exception of one. Line 32. Line 32. Assert initiated time. Here we go. And everything passes. Excellent. Now on to the next ones. Here we can just duplicate this and duplicate this again. Email rejected. All right. Email accepted. And then we'll change the event. And of course, we need to change this. And if I remember correctly, we don't actually have control or a message of that type. So here's what we're going to do. Okay. We're going to paste this. And we're just going to copy that. And same with email rejected. And there we go. Let's see, registration, user ID, email address, time, process time. Yeah. Okay. Okay. Okay, so we've got those messages loaded up. Now we need to load up the controls for those messages. So email accepted, email rejected. Let me just organize everything, or rather close everything. And yeah, I'll duplicate this and duplicate again. And then go here. Whoops. Right. And then go here. Right. Okay. Just making sure. Whoops, I lost it. Email rejected. Right. Okay. Let's see. Right. So we've got all of our controls correct, but the projection isn't actually doing anything. And we just copy and paste and copy and paste and of course we need to update this. And of course we need to update this. And this. Okay. One more thing. We also need to have a canceled event for our projection. Cool. Let's see. All right, controls. And then okay. Here, now we just go to the projection and copy this. And then and we're good. All right, so the projection's updated, the entity's updated. What next? Well, we have to update the handler. Let's see. Let's close everything here. And then let's look at the handler. So we don't want to write a registered event following the register command. We want to actually write the initiated event following the initiated command, the register command. So here, let's see how that does to the tests. Obviously, it fails. Close this. And we actually want to rename this to initiated. Here, we're really expecting it to be an initiated event and not a registered event. And same here. Okay. And same here. Okay, let's see. Yeah, okay. So that worked. Okay, so we updated our command handler to take a register command and write an initiated event. Okay. And then what we want to do is with this initiated event, we want to communicate with the user email address component. Okay, something we need to remember, something we need to know or understand about the user email address component is that it's not directly related to the registration component. And in fact, this user email address component knows nothing about the registration component. And yet, and in fact, there could be hundreds of components that are communicating with the user email address component, trying to reserve or claim email addresses for users. Registration component is not the only method for users to create accounts, most likely in the system. So we need a way to differentiate registration components that are trying to claim user email addresses from any other component. And the way we do that, here. The way we do that is with something called correlation streams. And the way that works is it utilizes a property of oh, I don't have any messages. All right. Let's go ahead and let's write one. Cool. Oops. All right. The way we do this is that, actually, let me go ahead and run this. All right, so our command handler handled the message and wrote an initiated event. So now we have two messages in the message store, the command and the event. Now, each message not only has data, but they also have metadata. And this metadata is used by the Eventide toolkit to store information about the message related to that toolkit. So like causation message position is the message that immediately caused this message. So this message was caused by this command. And then the causation stream name, the stream name of what caused this message right here. And then the global position is 1, as we see up here. Okay, but there's something else called a correlation stream name. And what happens is if a message has a correlation stream name, then that correlation stream name is automatically copied to any subsequent message that is written to the message store as a result, as like a sort of result or response to that. And let me show you what that means. The best way to do that is to actually just do it. Okay, let's see. So let's go ahead into this test. We're going to modify it a little bit. Okay, we've got our attributes. Now we want to write a test about metadata. So we're going to do test that it correlates with registration stream name. And then we want to we have stream name here, but I don't want to duplicate it. So we'll go ahead and write it here. And then what was that? All right. Registration ID. Let's see. Registration stream name. And then, so we're writing a test for metadata. We're going to assert that the initiated metadata correlates with the registration stream name. And that basically just means that this test is basically saying, does the initiated metadata correlation stream name equal registration stream name? Okay, that's basically what it is. But it's just a bit of a helper method. So let's test that. We see, oh, nope, failed. Undefined method metadata. Right, it's nil right now because we haven't actually, our handler doesn't set metadata. So let's go into our commands handler and go ahead and set it. Right here. Initiated.metadata correlation stream name equals to stream name. Okay. Oop, no, the reason that test failed was because I had a typo. All right, so it works. Now, let's go ahead and go back to here, our pSQL, truncate the messages, and then go back and write our register message and have the handler handle that message and write the initiated message. And as we can see, in addition to our causation metadata, we have a correlation stream name here called registration ABC. This correlation stream name will be copied to every subsequent message that any subsequent message of this process. Okay. So if a handler handles this message, then this correlation stream name will be copied over to the next message. And if a handler handles that next message, this correlation stream name will be copied over to that message. And this is incredibly useful for us, as you'll see. Okay, so next we want to do something when an initiated event is written to the message store. So that we need a separate handler. We need to handle events. Okay. So we have initiated, and we want to send a claim message to the user email address component. Let's just do some boilerplate. Okay. Oopsie. Here we go. So we need a handler. So let's go ahead and add that. Okay. So we have our handler. Let's copy this. Paste. Rename. It's very similar, and we don't really need any commands. And I think this is correct, and we can just get rid of all this entire thing. And maybe we'll just say, hey, handle initiated. But we don't yet know what that will do. Let's actually close everything here. Here we go. This is all we need. All right. So here we need something else. We need another dependency here. Wait, no, we don't. Never mind. Okay. So, much like the one here, this test here, we're going to set process time here. And I think so. Yes. Okay. And then we're going to get a sample initiated event from our controls. Registration ID. Okay. This will be user ID. This will be email address. This will be time. Oh, I don't need this. Okay. Let's see. And then we want to, let me just make sure I have this correct. Let me go look up the, so we need claim ID, encoded email address, and user ID. Okay, so for the time being, we're going to use registration ID equals will be the claim ID. For email address, we've got email address and the right. Okay, we don't need this. So next up, we have we're going to handle the initiated event, and then we're going to check the writer. And then we're going to look at the message. And then we'll test that the claim command is written. User email address stream. And we've all seen this before. Writer.write written claim. And this will actually need an encoded email address. So let's back up here and grab one from the controls. User email address, client controls dot, where is that? Right. So it's user email address dot encoded email address. Okay. And then we want to assert that it was written to the stream. And then right here, we want to test the attributes. And right now we'll do claim ID. And actually it's registration ID. Whoopsie. copy, paste, and this will be the encoded email address, user ID, email address, and time. Email address. And then this is here we actually want process time. And we want to parse that into a string, and then right. Okay. And now this is a lot of tests. And of course they all fail because nothing's happening. So we need to go here into our handler, and we need to actually get the registration ID from the initiated event. We also need to get the user ID and the email address. And then we're going to want to encode the email address. But we can do that in a function here right now. I'll just do that right here, rather than worry about it for too much. So I think this is what we came up with. Right. So we've got our encoded email address, and we want to go ahead and make a new claim. We want to have our metadata follow the initiated metadata. And then we want to set the claim ID equals to the registration ID. We want to set the claim encoded email address equals to the encoded email address. The email address equal to the email address. The user ID equal to the user ID. And the stream name equal to user email address command encoded email address. And then we want to write that. Now you may notice that we're not using any expected version. We're not using any idempotency protection or concurrency protection, and that's because we're writing a command, which we don't really need that many protections for a command. And for this, we'll go ahead and create require encode email address. We'll go ahead and copy this, move that over here. We'll make it a module method. we'll delete this and we'll just include it here. Include. And that makes it a little bit cleaner. Let's go ahead and test this. Undefined method encode email address. For handlers. Encode email address. Oops. Email address. Right. So here we have undefined method. Maybe this is wrong. Maybe it's supposed to be just like this. Uninitialized constant. Right. So the way we can fix that is just by including the client messages. So we could do user email address, client messages, commands, like that. Oops. I didn't, yeah. Okay, here we go. So time is not being adequately set. So let's look at that test. And I also noticed this one right here is incorrect or unneeded. Okay. Right. Okay, so I haven't set time. So we just need, so for time, we just need to do something like time equals clock.iso 8601. And then we just need to set claim.time equals time. All right, all the tests pass. Let's go ahead and let's look at these messages again. Okay, there's only two messages. So we already have an initiated message here. So if we run, but we need a, if we run the component, we should get a claim message written. But before we do that, we need to actually create a consumer for that. Let's go ahead and select all, copy, paste. Okay. We're going to need to add it to the loader file, and then for the start file, we're just going to need to paste this here, and then we need to read from a different stream or category, and that category is the registration category. And I think with that, we can go here, and we can see, yeah, a claim message was written. And if we go here, we have 3 messages now. This is the most recently added one. It's a claim message with time, with a user ID, with a claim ID ABC, with an email address, and with an encoded email address of this. And if you can see here, like I said before, the correlation stream was copied from the metadata of the previous message to the subsequent message. And that'll be very important for us to know which of these claim messages actually belong to registration. Okay. Okay. So once the claim command is written to the user email address, it's now out of our hands. Okay. We ran this, and now if we go ahead and run, say, the user email address component here, we'll see what we get here. So we got a claim message. And let's go ahead and actually, we can read the messages from the message store. So we know about these 3 messages, okay? Now we have a second claim message written to the transaction stream. Okay, this is an item, this is the reservation pattern that preserves the idempotency of this particular claim, because we could have multiple claims with this data of user ID 123, email address jane@example.com, so on and so forth. This claim ID is what makes this unique. And then once we have that claim message written to the transaction stream, we read that, and we now know, hey, there hasn't been any prior claims to jane@example.com. So we now write a claimed message to the events message store. Now, once we have this, and as you can see, the registration ABC stream name has been copied to the correlation stream name of every subsequent message. Now that we have this, our registration stream name needs to be able to read those messages from the user email address component. And this is where the magic of pub/sub comes in. All right. So we actually need a new handler, because our current handlers, this command handler is reading from the registration command stream. And this event handler is reading from the registration event stream. So they can't be used to read from the user email address component stream. So that's what we need. We need a new handler to read from those from the user email address stream. So let's go ahead and read from the user email address events. It's very similar here. We'll just copy this and then paste it. Okay. And then we'll just add this module here. And then we'll go ahead and get rid of this. And we don't need this. And we don't need this module. These dependencies look good to me. And let's go ahead and write the different handle blocks. So we want to handle the events claimed from the user email address component, but we also want to handle user email address client messages events rejected, or claim rejected, I believe it was called. Okay. And I'll go ahead and write tests for this. And there we go. A lot of these will be very similar. So I'm just gonna do the old copy and paste. handle user email address events. Claimed expected version. So here we're going to use this handler user email address events. And actually, let me go ahead. Right. So we need a claimed event from the user email address client controls. And then we get our version. We add that. Let's use an initiated example. And then we add this. Like so. Then we want to handle it, and then we're going to say email accepted. Undefined method local variable register. Okay. Unexpected end of the input. Okay, so what it's saying is that this failed because there's nothing written here or here, right? Okay, let's go over this one more time. Claimed registration.id. Right, okay, that looks good to me. Let's go to the next test. Ooh, okay, let's just copy this. Paste. Oops. Paste. And we want the email accepted version. Okay, because this is the ignored test. All right. Okay. Of course. All right. And then here, yeah. Pasted. Okay. We'll copy this. Paste it here. And then we'll copy this event. Okay. what we need to do is, there might be something we're missing here. Well, first of all, we need to rename this to email accepted. So what I'm thinking is that our test here is expecting a registration ID in the or a correlation stream name. So we need to add a correlation stream name to the metadata of the of this message here. Yeah. So let's go ahead and do that. And then set this. And then here, right? I think that's what we decided. And here's where it's getting confusing because claim ID doesn't necessarily have to be registration ID. And in fact, I would much prefer if claim ID was its own thing. So actually, let's go ahead and do that, and then we'll come back to this test. Let's go ahead and move these out so that I don't have to deal with them. All right, so what we want to do is, oh right, we want to get rid of that. But right now we'll figure that out later. So we'll just add a claim ID here, and then in our controls, we will add a claim ID. We probably want to add this here. What are we using here? I wonder. It's just id.example. Okay, that's good enough for me then. And then we will okay. All right. Has no setter for claim ID. That's right. We need to add it to events, to our initiated event. So okay, so that's added there. And we need to add it here. Okay. Let's test this out. Everything looks good, but let's just let us just go ahead and check our tests. So projection initiated. Ooh, are we going to need to change anything here? Let me think. No, I don't think. I think mostly we'll just need to change this here, our handle command, to make sure that claim ID is properly set here. And that is done correctly. And then when we go to our handle events, we need to make sure that our claim ID actually equals claim ID. Okay, and I think I know where that problem is. Pretty self-explanatory here. We're not going to get registration ID here. Okay, cool. And while I'm here, I'll go ahead and update the right class here to accept a claim ID as well. And then we'll just pass it in here. Okay, that looks good. And of course, we're going to need to update our interactive script. And we'll just use a truly random claim ID. Well, maybe not, because I do want to demonstrate this. So we'll just use AAA. Okay. Okay. Let me go ahead and add these back in. Okay. So let's go back here to the top. So we're going to need a registration ID, and we'll go ahead and just grab that from our controls, right? So we're setting the correlation stream name to this registration ID. And now our claim ID equals, actually we don't need claim ID, but we do need user ID. Oopsie. Claimed. And then the effective time is claimed. Okay. So then we're handling the claimed event. And then we're going to make sure that email accepted is written. And we don't need this metadata test, but we do need, hold on, let me check my message. Okay, good. So I think everything here is correct. We're getting registration ID from the correlation stream name. We're getting user ID from the claimed message. We're getting email address from the claimed message as well. And we're getting the effective time from the claimed message, but we're getting the process time from the clock. And I think that's correct. But now I need to update these as well. So let's copy this. And then let's put it right here. Registration ID, registration stream name, correlation stream name, and then we've got a registration. And then we've got a version, and we're adding that here. Claimed, right. Yep. Written to version, written to stream, got it. And then similarly on this ignored test, let's just put it right here. We need to set the stream name, the correlation stream name, and these tests should be correct. But of course, we need to write code here in the handler. And this code is actually very, very similar to this code, right? So let's just copy this. The only thing that's different is that we're not getting the registration ID from the message. We're actually getting it from the correlation stream name. So we need to grab that. Okay. And then we can get the registration ID. And there's actually this helpful method on the stream name module called getID, which will help us do that. So we just pass in the correlation stream name. So in this case, registration -abc, and it'll return ABC here. And then we just do the normal thing. We just fetch the registration from the store. Okay. We have to make sure that for our idempotent check, we have to make sure that the registration was not already have a state of email accepted. If it does, then we ignore the event. Registration ID, user ID. Okay. Okay, then we just set time. We've got the stream name from the registration ID, and then we say email accepted, follow claimed. And then we don't set the correlation stream name, but we do set the process time, and then we write it to the message store. Okay, has no setter for claim ID. So what we need to do here is this follow method will take all the attributes of this claimed message. Let's go ahead and look at that. Claimed. It will take all these attributes and then set those values on our email accepted. Oops, that's just the control. Set those values on the email accepted event. But as you can see, we don't have a claim ID or an encoded email address. We don't have a claim ID. We don't have an encoded email address. We don't have a sequence. So we need to ignore those here because this is just going to copy them straight. So what we do is we set exclude, and we exclude the encoded email address. We also exclude the claim ID and then the sequence. And I think that's all we need to exclude. Oh, also, before I forget, we actually need to set the registration ID equal to the registration ID because we retrieved it from the correlation stream name, but not from the message, right? Okay. Oh, and all the tests passed. Let's go ahead and copy all these guys and paste them here because it's pretty much the same. Okay. Rejected. Claim rejected replaces claimed. And then let's go ahead and grab this. Email rejected. Oh, whoops. Okay. Email rejected. And then I think that's it. Let's go from the top. We want this handler. We want this event. We still need the correlation stream name. We need, we handle the event. We check to see that this event was written. Okay, yeah. Let's go on to the next. Oh, we do need to claim rejected. Let's just update it for everything. For all the tests. Okay, and then here, let's go ahead. Claim rejected. This looks good to me. Version boom, 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 boom. Email rejected. This looks good to me. And then okay, let's see. I think that's it. Okay, yeah, that looks like what I was expecting. And then here we can just copy all this. This is just tedious work at this point. Okay. And then we want to change this to email rejected. And then we want to change this to email rejected. This also to email rejected. And let's test. Yep, and of course, our tests passed. Okay, and let's go ahead. And actually, we're going to need to close this, clear. Let's go ahead and truncate these messages and write a new one. And then we will go ahead and start the component. So right now, we've written our initiated event. We've got our command, our register command right here. And then we've written initiated events, and also we've also written a claim command to the user email address component. Now our user email address component is not on, so let's go ahead and test start that component, and we can see that it wrote the claimed event, and back here, the claimed event. Oh, I know what happened. If we go ahead and see here, the last message is just the claimed event on the user email address component. But here, we forgot one thing. We forgot to add a consumer. All right, so let's go ahead and add that. All right, and here, for this consumer, we're actually going to do something a little different. It's going to be very much the same. I'm going to duplicate this. Okay. So here we have module user email address. And here we have our user email address events handler. Now, if you saw this, when the component first ran, it noted that position is stored in this location. Let me see. This location. Now the thing is, this component has its own position store. And if we run a consumer on the exact same stream, in this case user email address, then they'll interfere with one another. So we need to set a identifier here of registration, so that when this consumer is running on this stream or category, it's not actually interfering. The position identifiers are different. Next, we need to go to the start class, and we need to go ahead and now, similarly, it's actually very similar, but this is also going to be a little bit different because we're not just running. We're not just interested in all events from the user email address component. We're interested in that which is correlated to this category. Okay. So to denote that, here we say correlation registration. And then I think we can go ahead and restart this. And as you can see, it's actually writing the message email accepted to the message store. Let's go ahead and look and see. So right, you can actually see here that we actually have a duplicate claim message, but that because of the claim ID, that it wasn't this message wasn't reprocessed. So that's good. Our idempotent protections are in place. But the one we're looking at here is this email accepted message or event. It's still got the correlation stream name, but we now know that, hey, this email accepted event, that this email was accepted by the user email address component, and now it's written to the registration stream. Now, next once we have that email accepted event, we can write the registered event. Or if we have an email rejected event, we can write the canceled event. Now, I said I wanted to remove the process time here and here because they don't really serve a purpose, because process time and register time will be the same. The effective time of this event doesn't correlate to when this email accepted event happened. There could be other checks here, or other steps in this finite state machine that we just don't know about yet. So right now we're going to make it so that this time, the effective time, is when this event was actually written to the message store, not when this event, not during this event's effective date. Okay, I wonder if that broke anything. Yes, it did. I think I need to remove that from here and from here. Okay, excellent. And then we need to create a handler for this, and that will be in our handle events. So we have email accepted and email rejected. Okay, so close other tabs. Excellent. So actually, these again. We'll use these, and we'll just paste these here as well because we're going to use those. And this is just very similar. Okay, so it's not a command. We're taking an event, an email accepted event. Right? We can go ahead and say email accepted for this registration. Boop, boop, boom. And we want to make sure that a registered event, whoops, similarly here. Similarly here. Wait, did I want that here? No. No, wait, yes. This is correct. This is incorrect. Cool. Excellent. Then we take this. Okay. Okay, we don't care about that. All right, fix the typo. Let's see here. I don't think I need effective time. Certainly don't need metadata tests. And this is will just be here. Right. Cool. To the registration, stream name. Okay. That kind of looks like what I want, because I know these tests are supposed to fail because I haven't actually done anything yet. I'll go ahead and just consolidate this. Okay. This all looks good to me. And we've got our processed time here. All right. Let's go ahead and go to the handler. And right, here we go. So we're going to add a block, handle. Actually, let me go ahead and, this is just so. What does paste this? Okay. So obviously we're not handling register commands. We're handling email accepted events. And okay, then change the predicate, change this, event ignored, event email accepted, message type, registration ID, registration ID. Yeah, that's good. And then we've got the time, we've got the stream name, we've got the event, and we're not going to do correlation. Yeah, that sounds good to me. Ooh. Let's see what is breaking here. Expected version and first of all, this should be renamed to registered, but I don't think that is what's broken, obviously. Let's see, has no setter for processed time. Right, okay. So similarly in that previous example of time, we need to actually exclude process time. Yeah. And now just one test is failing. Let's go up and look and see what exactly is failing. Okay, pretty much the entire thing. Let's go ahead and see. So this looks good. We need the time. We need the stream name. We're following the registered with the email accepted event, and we're writing it to the stream. Let's look at the test. So, oh, of course. And it's just right there. Claim ID, undefined, line 44. Of course. You don't need that. Registration, user ID, email address, time. And excellent. Okay, now on to the canceled event. And actually, I'll go ahead and delete these and use these. Paste. And we want canceled. Okay. So this is going to be email rejected, and this is going to be canceled. Similarly, and this is just going to be copy paste straight down the line. Correct. Okay. And here we go. Email rejected. Okay. And then the ignored tests. Okay. All right. Oops, I didn't write the handler. I can just copy this. Copy. Paste. Okay. Email rejected. Email rejected. Canceled. Yeah, that looks good. And then canceled. Canceled. Excellent. Okay. Let's go ahead and actually let's go ahead and look in. I think this email accepted event is still in the message store. So if we did everything right, then our component should pick up that email accepted event and write a registered event. And it looks like it did do that. Let's go ahead and see that again. And we'll go ahead and get, actually, this is getting a little bit cumbersome. So let me go ahead and order by global position ascending. And we see the top event is registered. And as you can see, this claim message, this claim command message is going to be written every single time this component is restarted. But again, it doesn't matter because our components are idempotent. All right, now let's see what happens when someone else tries to register this email address. So we'll go ahead and do 456, and we'll say BBB and DEF. Okay, but the same email address. So a different user with a different claim ID and a different registration. We can already tell that this that the whole workflow went through. Even the user email address component says that this email address was rejected, And so the registration was canceled. But let's go check PSQL. Let's go ahead down to the message that we wrote. Okay, so we wrote a register command, DEF, for the registration DEF for user 456, but with jane@example.com. And then we go here, we wrote an initiated event in response to that with the correlation stream registration DEF. And then we wrote a claim command to the user email address command stream with this encoded email address ID, with this claim ID BBB, email address, and so on and so forth. And the correlation stream is persisted. And then we write it to the, we copy that message to the user email address transaction stream in order to use the reservation pattern to make sure that this BBB claim ID isn't duplicated or processed twice. And then we write a claim rejected message because we already have a claim. So user 123 already has a claim to this email address, so it was rejected. And then because it was rejected, the registration component saw, using pubsub, saw that, this email address was rejected. That means I have to write that this email is rejected to my own stream. And then we can cancel the registration. So you can see these components working in concert with one another. Let me go ahead and truncate the table. Okay. Let me go ahead and undo my changes here. I think this component is now done. It goes through the entire business process of registering or handling user registrations. About the only thing we need to do is the exact same thing we did for user email address. We need to write the client gem spec. So we'll go ahead and add a registration folder here. We'll add a client file, and this will require the messaging Postgres library from Eventide. It will also require all the messages from the component, and we're going to need to set our namespace, our client namespace. So let's go ahead and do that. So here we just go ahead and say module registration, and then module client messages equals to the registration component messages. And then of course we're still going to need our controls. So we can go ahead and say registration component controls, module registration, module client, and then all the controls equals to the registration component controls. And I think that is all we need for this client. We've done a lot. We've created a registration component to handle user registrations, and it will let us know if an email was rejected or if a registration was completed. We also created a user email address component that the registration component communicates with, which is now this component, this user email address component, is authoritative over email uniqueness. Okay. Now we just need to continue forward. We need to hook up all these components to our registration resource. All right. Let's see. Quick recap. We've created a registration component, and we've created a user email address component, And we want to hook that up to our registration resource, our REST API, so that our web UI can use it. But before that, we don't have any way to query this data. If you look here, well, there's no messages, but actually, maybe I'll just add some. All right. So if you look here, this isn't really easily queryable. This data. I mean, we have messages here, but the data that we're interested in is in this column, this JSON B column, and so we don't really have we need a way to easily query this data so that we can use it in our application, and that means we need Vue data. Now, what I like to do is store Vue data in a completely separate database from the message store. The message store is really supposed to be a permanent storage for your events and commands and messages in general. But your Vue data is far more ephemeral. It's final state data, so it's going to be written to quite a lot. And sometimes there might be bugs, and you want to just drop the database and start with a new one. So that's what we're going to do. We're going to use a separate database. So let's go here and go ahead, and as you remember, we have our message store is using a Postgres image, and so we're using containerization in order to create different database servers that are accessible through these ports. And so I think this is how you do it. Yes. Okay. So let's just change this to Vue data. And we want it stored in a completely separate volume. And we want to use a different port. And now we can just Docker compose up. That will start our containers. Let's just take a look at it. And it seems our message store is up. I don't see our Vue data. Oh, here we go. Yep, ready to accept the connections. Excellent. And we can also see our containers here. Cool. And now let's try connecting to it. So we need a separate port and our user. Yep, now we're connected. There's not really anything here though. So let's go ahead and rectify that. So if we look here, we have a schema for our database message store and our registration service. We want to create a completely separate schema for registration Vue data. So let's do that. Oops. Okay. Okay. So we've got our folder here. Let's go ahead and initialize a project skeleton. All right. All right. Let's add this project here. Database. Data. All right, let's take a look at our configuration. That's not really what we want. So we'll just do a couple. We'll just do a copy paste. And, okay, so we want to change that, and we want to change the database itself. So the server is going to use port 5433, and the database is Vue data. And we actually have to go ahead and create that database, I believe. And the database will be called Vue data. Excellent. Let's just check to make sure that that happened. Excellent. Okay. So we've got our configuration set up. Now what about this? Let's add a location. I'll just copy it here. Cool. And I believe this is all we need to configure a sketch project. What I like to do in here is remove the public schema. So let's go ahead and do that. Right, so we have our three scripts: drop, deploy, revert, and verify. So for this kind of thing, I just add this drop schema, and I don't do a revert because I don't want the public schema to be there. So we made that we did that migration, and there are no schemas except for the sketch schema. Next, I want to add a registration schema. So this is where all of our registration Vue data will be housed. Oops, I forgot to add a note. Okay. So here, let's create our schema. And here I really will do a correct revert script. And I'm not going to bother with a verification script. Okay. Excellent. Let's see. So we've got our registration schema. Next, I think we'll want a registration table. So let's go ahead and add that. So we're going to want to add tables, registrations, and we're going to set a dependency to the registration schema. And what that does is Sketch will make a sort of map between all the dependencies and make sure it migrates these in the correct order. Okay, where was I? Right, I'm creating the table here. All right. So let's create the table. Inside the registration schema, we're creating a registrations table. Let's complete this. All right, so right off the top of the bat, we're going to want a registration ID, and that'll be a primary key. And then we'll have a user ID and an email address. Additionally, we're going to want, I think, remember our payload here. We want to return this payload. So we're going to want our is email rejected. And is registered. I think we're also going to want a like this is a UUID key, and so I think we're going to want a big serial. So what I like to do is use the name global position to indicate a big serial, and this is just an auto incrementing key. And then sometimes it's useful to have date stamps. So we'll have a created at field time zone, not null. And I think this is enough to be going on. And here on our revert script, we're obviously going to want to drop the table. And for our verification script, we'll want, this is the way I do them for tables. Whoops. Select from registration dot where false. And this means if if this table doesn't exist, then this query won't work. So we have registration ID, user ID is email rejected, is registered, global position, and created at. And so we can deploy this. And then let's take a look. Wrong. Right, okay. So we've got our registration schema, and we've got our registrations table. And what is the command to know more about the table? Here we go. Okay, that looks good. And we can see we've got our index here, our primary key index, and we have an auto incrementing sequence here. And that's what we're expecting. So we've got our table. What we need now is to set roles and privileges. So in my mind, there are two roles here. There's going to be a registration view data component, and that component is going to need a role to this database. And then there's going to be a registration resource, like this project here. So we'll need a role for that. So that's two roles, one for registration resource, one for registration view data. So let's go ahead and do that. We'll do view data first. And let's just go ahead and add it now. Registration resource. Okay. Let's do this one first. Okay, so let's create the role registration view data login inherit. And let's add a search path. Right now we've got registration schema and public, but actually there's no public, but I'll just leave that on there. But we also want to add message store. But this is probably not going to work because message store doesn't exist on this database yet. So let's rectify that. Right. Okay. We're going to need to go to this database. Actually, no. Create DB. Okay, and then we'll create message store. Okay. Now let's go to database message store and let me just check the configuration files. Yeah, we've got a target for view data. So let's go ahead and sketch deploy view data. All right. Okay, yep, we have a message store. So we can set the search path to message store. And I also want to grant our message store reader role to registration view data and grant the message store writer role as well. Okay. And our revert role is very simple. We're just going to drop the role. And then I believe if we go here, we have a verification script that we can yoink. registration view data. Okay, let's deploy that. Ooh, whoops. I didn't want to do that. Let's revert. What happened here? Registration view data. Is it the revert script? Ah, yes. Oh, and if you want to just do it, you can just do this to auto without any prompts. Schema registration does not exist. Oh. Huh. Okay. Okay. So we reverted all of that. So here, it's going to be a little bit more simple. We just want to create the role. And set the search path. Okay. And here, we just want to drop role registration resource. And yoink that. Okay, registration resource. Yes. And now we can. Why do I always do that? Okay, all that looks good. Okay, so we've got our roles. Now we need to set certain privileges. Okay, so because this doesn't have access to our registrations table. This doesn't have access to our registrations table, so we need to grant access. So what I like to do is, let's see. Actually, so we want to say it requires roles and schemas. And yeah, let's just do this for now. Okay, so we have our privileges. And this is registration view data. We want to grant usage on the schema to our role. And we also want to grant select, insert, update, and delete on our table to the registration view data role. And we want to grant usage and select on our sequence. If we don't do this, then any inserts that we make will automatically fail. Let me make sure that this is the correct name by going into PSQL. Port user and database. Um, registrations global position sequence. Excellent. Registrations global position sequence. Okay, and that's it. For our revert script, it's pretty much the same thing. So I will copy this. And paste. It's the same thing, but opposite. So instead of grant, we say revoke. And instead of to, we say from. So it's basically the exact opposite. Revoke usage on schema registration from this role, and so on and so forth. Now for our verification script, you can use Postgres functions, pg catalog dot has schema privilege registration view data, I believe registration. Whoops. This is the actual schema, and then this is the whatever usage. And you can do the same thing for tables. Has table privilege registration view data registration.registrations and select. And let's go ahead and paste for insert, update, and delete. Insert, update, delete. And you have another function for schema privileges. Sequence. And it's also relatively straightforward. And that's it. Okay, error. Registrations schema does not exist, so I have a typo here. Cool. And let's create a new script for our registration resource privileges. This will require our roles script. And our tables. Did I do this correctly? No. I can just edit it and this is right. All right. Okay. Very similar here. These permissions. So I'll just copy them and then use them as needed. But Remember, our resource isn't writing to this database. That's the job of our view data component. Instead, what we need is we just need to be able to select. We just want to be able to read. And like that, and by that token, we don't need any permissions on the sequence. We just want to be able to select on this table. So let's copy this. And for our reversion script, we want to say revoke from. And here we can copy this. Oh, wait. Did I do this correctly? No, I did not. I need to change it to this. I need to change this. And likewise, I need to change this. Everything else should be correct. And I can deploy. Cannot find change. Okay. All right. And these should be all the privileges and resource all the privileges we need. Something we also need to do is that our registration view data component, which we haven't written yet, admittedly, needs to be able to access the registration service, this database, or at least the message store, because it needs to be able to read messages from here. So we'll add a role here. So here we are. So let's add a role. And there we go. And actually it's just a straight copy and paste for our role here. So we just change this because we want to be able to read from the message store and we want to be able to write to the message store. Now, why do we want to be able to write from the message store if all we're doing is just reading events from the message store? Well, we need to be able to write because periodically, like every 100 messages or so, but this is also configurable, the consumer will write a position message to the message store to keep track of where it is. So that if you have a catastrophic failure and the process shuts down and you restart the process, you don't read messages from the very beginning of the message store. You read from your last position or bookmark. It's basically just a bookmark. So that's why we have to give it write permissions. And just drop role registration view data. And to verify, we'll just copy and paste this. Paste this, checks to see that it exists. Sketch, deploy. Okay. Now, while we're here in this project, we actually also need a role for the registration resource, because the registration resource needs to be able to insert messages into the message store. The registration resource is querying data about registrations from the Vue data database, but it also needs to be able to insert messages to the message store. I know this sounds confusing, but I promise that it'll all make sense. So let's go ahead and do this. Okay. This looks good. So let's just copy this. And then we'll paste it here. Well, we'll set that. Now, here's an instance where we don't need to read messages from the message store. We only need to write messages. And so that's why we're only granting the message store writer role to the registration resource. Drop role. And cool. That's done. So now we have our database schemas for our Vue data. Now we can create a Vue data component for registrations. Okay, so we've created the database schema for our registration Vue data. Now we just need a registration Vue data component. So let's go ahead and do that. We'll create a directory. And let's initialize get repository. Registration. Can I spell? Now let's add that project to our editor. Registration Vue data. All right, now let's set up the project skeleton. Okay. I think I will copy and paste most of this stuff. I don't need a client. I'll grab the test folder in a bit. Okay, just pasted that. Now I have to be very careful. This start script is going to be a little bit different. Okay, and then let's see. We're going to have to do something a little bit different with the settings file. And I'll go into that in a little bit. But right now, I'm just going to say this. Copy, paste, rename. Okay. All right. Okay. This looks good. Looks good. This is fine. This is fine. Ooh. Okay. And then we're going to want this to be a registration client. And one more dependency we will actually need is and this is my own Postgres view data library, which will allow us to insert records with Postgres and read records. And the reason I use this instead of an ORM like Active Record is I guess because I'm not really a fan of Active Record, and I wanted a lean package that just did one thing well. I think that's it. Registration view data. Let's copy the test folder. All right, I don't need all of this. Look, I don't need these tests. So let's delete that. Database connection. This is not going to stay here, but it's just a project skeleton, and I can delete this. Tag messaging, store. Okay. I think. Oh, right. Okay, so this is right. This is correct. Correct. Okay. This one needs to be changed. Registration. Client controls. Okay. I think that is all of that. Now I need to make those scripts executable. Let me see, what other scripts do we have? Okay, we did that one. We did that. We did this. Okay. All right. Let's install our, oh, right. Could not. Oh, right. So I don't have this in a package right now, or in a package repository right now. So I need to actually define this gem. And same for the registration client. Okay, we installed our gems. Does the test work? Right. Cannot load such files. Eventide, Postgres. Right, the file. Well, that's as far as we can go there. So I'm going to go ahead and check this in. Okay, so we have our project skeleton. So as you saw, there were certain things that weren't working because the settings is a little bit different here. And that's because with this component, it's assumed that with the registration component and the user email address component, it's assumed that they're just reading and writing messages to the message store. But here, this registration view data component, we have a lot of different connections. We have connection to the message store to read those events, those registration component events. We have a connection to the view data message store so that we can event source whatever this view data component does. And then we have to have a connection to the view data database where this schema lives, so that we can query and insert records or tuples into that database. So we need 3 connections. And so we will go ahead and we'll use something similar here. So I don't want to throw this away. Right here. But we'll have several different things. So we'll say something like this. Copy. And so this is the component at large. What we want is our entity message store, settings for that. And that could be this here. And we want a view data message store. Similar thing here. We'll replace that. And we want a view data connection settings. And I'll just paste over some. Now let me see if this works. Right. Okay. Okay. And so here we'll paste that. And there's certain things we need to fix. Our role is registration view data. Remember, we set that up. Similarly, registration view data and registration view data. Everything else looks fine. We don't have a password or anything. All right, so how do we get those things. How do we get that set up? Okay, well, first, let's require this library, settings. And this is an Eventide library, which will read, which can read files, JSON files, and set up objects with that data with the data inside here. And we already use this. The base component already uses it, but it's kind of hidden away by the toolkit. So now we're really opening the guts and using the toolkit in earnest. So we want to set a settings file here. So what does that look like? Well, we have our namespace for registration view data, and we have a class. And we want this class to inherit from the base settings class. And this is just boilerplate at this point. Now, this is a singleton that will build itself using the build build factory method. But that's defined on the base class here, so we don't need to worry about it. Where we do need to worry about is where we're actually getting our data from. And what I like to do is set a defaults module here and define it here. So what we're going to do is use settings registration view data.json. And sometimes what will happen is we may want to define this in a environment variable. But if this is null, then we'll just use the default defined here. Registration view data settings path. And we need to define the keys, which this library calls names. Entity message store, view data message store. Okay. Once we have that, we can define our so we need three different session objects to handle the connection information for our three different connections. We have three connections, we need three different objects. What was I thinking? Okay, so we need three different objects, but one of those objects for the entity message store, this is the message store where we're just reading messages, events from the message store in order to process those messages. This is where we're writing to, and this is what the database that we need to query for in our resource project. So this one is already defined. This session object is already defined in when you start the component, like say here, you can pass in a settings file. So we won't worry about that now. What we want to worry about is the view data session. So we'll create an object here. Let's first load it in. Okay, class session. And here we're just going to use the base class of message store, Postgres session. And we need to define, this is just boilerplate, we need to define all the settings And here we need to, and we also need to define the factory method, and this is the interface for it. So, how do we do this? We need to pass in a settings file. This into the to the parents build method. So how we get that is registration view data settings.instance, and this is the settings instance from here. And then we need to get the view data. We want the view data message store settings from here. And then we pass it. Then we generate some settings from the message store, Postgres settings, and then we pass it into the session constructor. Let's actually go ahead and see what this looks like. Okay. So what we want is to we need to require the file here. So now we have registration view data settings. Okay. And when we call the instance method, we can see, oh, there's some data in here. And it's basically a hash representation of this file. Okay. But we don't want a hash representation. We want to pass these settings into the session. And so let's just do what we did there. Okay, so, and then we want the view data message store. So view data message store looks like this. Now we can see, hey, we've got all the settings we need from that. Now we want to generate some message store Postgres settings dot build with those settings. Once we have that, we can build a session. Message store Postgres session. And now we've got a session. And then this session can be used to execute different queries. Case in point, let's see. And looks like that command was okay. So there you go. We can actually write a test for this. Yeah, let's delete this because it's not going to be used. And we'll do a view data. So we need to require need to set the parent context, database connection, and view data message store. And then we want to make sure that it doesn't, this is just boilerplate. And then we want to test. We want to make sure it doesn't raise an error. This is just the same thing we were doing. think this is the same. Why didn't I just copy and paste? I don't know. I'll just copy and paste. um, but I want to replace this. Let's test it. Uh-oh, cannot load such file. Automated init. Oopsie. Let's see. Undefined local variable and method registration view data for session. Did I make a mistake? Ah. Okay. Yep, that works. And we'll want to do one for our view data as well. Okay. Oh, whoops. I forgot to add a context here. Okay. Okay, it's very similar here, but we want to do this in a different namespace. We don't want to use the same class. And yeah. So let's go ahead and add that file. Okay. Oops, I did something wrong here. There you go. Okay. And we're going to just basically do the same kind of stuff, but not exactly. We are inheriting from the parent class message store Postgres session. We're doing standard boilerplate, and now we need to set the settings here. Here we want view data instead. And that's it. And it seems to work. And let's go ahead and test the entity message store as well. This is going to be a little bit more complicated. Because we don't have a session per se. So we need to build it from our class. Settings instance. Whoopsie. Um, so we want to build our settings. Entity message store. And we want to build and then we just want to make sure that this connection works. Undefined method instance. Oh, it's probably a namespacing issue. Undefined method settings for main object. Okay. Cool. So we have our connections set. Yeah. Now we just go about this the same way we would any other component. Let's write some entity tests. And we're really only concerned with the rejected and the registered state. So let's delete the rest. Registration has registered time. Controls, registration, registered. Yeah, this is all, we're going to use all this stuff. And here, let's do that. Email rejected. Okay. And of course, we're going to need controls. Require and then pretty sure we're going to need a registration entity. Now this entity isn't the same as the registration components entity. I mean, the code will be very similar indeed, but they're authoritative over different things. So they're just they're used to do different things, and we'll see that. Let's see. Okay. Save that. Whoa. Mouse. Okay. Don't want this. I'll probably need name. Registration view data. Okay. Let's keep these. And yeah. Okay. All right. So I'm not expecting this to pass, right? So we don't have a registration entity, but we can just copy that over. And again, they're not the same. They just look the same because they just look the same, but they're authoritative over different things. Like the registration component's registration entity is authoritative over this entire business process. But here, in registration view data, we just really care about, we want to be able to know we want to be able to know whether when we retrieve messages from the registration component and process them, we want to be able to write to the database, write to the Vue data database, and then we'll know, and then this entity will keep track whether that actually happened. Whoopsie. And that's really all we care about. Uninitialized constant. Let's see. Where do I want to put this? And our tests pass. Okay, now we want to do our projection tests. And they are also very similar. The places where it will differ are the handler, most likely. Let's see. Let's paste this projection, and we don't care about this. And oh wait, it seems to me I didn't do these tests correctly. That I may have done a bit of copy pasta. Yeah. Well, I'll go ahead and fix that now. Let's go ahead and acquired. Register. Oh, of course. Email rejected time is converted and copied. And now we have a passing test. Okay. Let's go ahead and copy this and then paste it here. And what we don't have are any events. So we're going to need those. And before we do the controls, let's go ahead and look at the messages. So we'll copy them here, paste them. We're also going to need a load file. We won't need any commands, but we will need some events. And looking at it, registration ID, user ID, email address, time, and process time. This looks fine to me. Here, I want to have process time too, because it's processing the registered event from the registration component. So everything here looks great. Email rejected and registered. And we're going to need some controls here. So events, email rejected. And let's just copy that from up here. Copy. Paste. Did that not do it? Copy. Paste. Let's delete the ones we don't need. Okay, email rejected. This all looks good. I might need this because we need a process time. Okay, now we get a uninitialized constant registration view data messages. Okay, we need to actually load our load file, event load file. So let's do it here. View data load. Okay. Uninitialized constant user. Oh, right. And we need the user from here. And keep forgetting. Okay, uninitialized constant projection. Oh, now we're getting closer. Okay, so we have our registration. Now we have our projection. And this one's going to be really similar again and again. I'm like a broken record. All right. Paste. Registration view data. We don't care about the initiated event or the email accepted event. All we care about is the email rejected event and the registered event. Remember that time. And our test pass. Now, before we do the handler, because let me show you here, and maybe you'll be able to see a little bit of what I'm thinking about doing. When we, this is a good example. So we have basic idempotent protections, and then we write an event to the message store. In between this, we can add something to insert a tuple into the view data database. And that's what we're going to do. And the reason we want to use the machinery of the handler is because we want to make sure we process these messages only once. And this is a good way to do that. And we don't need to have like a, and we are already using this machinery, this event sourcing component machinery. So why not use it again? Okay. Now, so we're going to be using my view data Postgres library. We've already installed it, but I think we need another library. We're going to need telemetry. Now, telemetry is used in testing to make sure that a class dependency was actuated. Now, this might take the form in like Rails in the Rails world as mocks, but we're going to actually code these in ourselves. as substitutes, and you'll be able to see that. So let's add the telemetry library. Let's add this package dependency. And then we want to install our gems again. Okay, all of our gems were installed, including telemetry. Now, we're going to create class objects to insert different tuples depending on different events. So when the email is rejected, we need to insert a tuple that it was rejected. And then when it's registered, insert. Okay. And let's go ahead and add these. Insert. Let's do insert registered first. Let's do namespacing. And insert registered. We're going to need the dependency library. And one of our dependencies will be the session that we have here. This one right here. And another one will be from the Vue data library, which is insert. This is a class that whose only responsibility is to insert data. And we're going to want telemetry. Now let's configure those dependencies. Because this class itself is going to be used in our handler. And we want to be able to pass, we don't want session to be passed in or to be generated for each of these things, because that then a lot of connections will be created. So we're going to reuse sessions. We just pass that in. And I believe this is all right. Let's build our factory method. Then return instance. And here's where we configure all of our dependencies. So we just do session.configure self and pass in the session. And then same thing with Vue data Postgres insert. And then we want to configure telemetry. And so here's what the API will look like. We're going to pass in registration ID. We're going to pass in user ID, email address, and time. And we won't do anything with this yet. Right now, I want to code in the telemetry and substitutes. So the telemetry for Eventide uses a very similar API throughout all of its telemetry. You need to define a module within the class you're using telemetry on. Then you need to have a sync and include this library. And then you have to record, you have to use this record macro to tell the sync which events you want to record. And we're just going to go very simple. Like, we're just going to record this insert registered event. But you can also use this to record certain data about it. But we're not going to do that right here. And then we'll also define a singleton, sync.new. And then we'll define what data we're looking for. So this is very specific. This is the name of the table that we're inserting to. This is the identifier. So this could be the primary key, or this could be like a collection of columns that act as a key. And then here's just the data we're inserting into that. And then once we have that, we need to actually define a register telemetry sync method. And what this will do is when this is actuated, it will grab the sync and then set the sync to the telemetry dependency on the up here. Wait. And then I think that's it. Yeah. Okay. So we have, this will allow us to register our telemetry sync. Now, why are we doing all this? Because when we have our handler right here, say, let's just use this as an example. When we have our handler and we're testing it, we don't actually want to actuate all these dependencies. Because if we do, then we'll be actuating I/O, or actual database. We'll be using actual database queries and inserting into actual database records, tables. So we want to substitute this when we're using it as a dependency in a test. We want to substitute this so that it is not actually connecting to anything, and we do that with a substitute. And the way this works is the Eventide dependency module will use reflection, and if you don't use build or do these if you don't configure anything, so basically if you're just doing class.new instead of class.build, these dependencies will remain inert until you actually configure them. And when they remain inert, what that means is that it will go look into your class for the substitute module. And inside the substitute module, it will look for a build factory command or build factory method. And if it doesn't find that, then it will set these dependencies to a null object substitute. But if it does find that, then it'll use that. And with that, you can do certain things like use predicates in your tests if you have them defined. So let's go ahead and build our substitute. So inside our substitute factory method, we want to actually set our telemetry sync. And then we set a subclass, registration view data command insert registered. And we want the sync to be accessible. And let's build a build factory command for this. And we configure telemetry. But we don't operationalize any other dependencies. So it won't actually insert into the database. Now, once we're here, we can go and insert using our APIs. So view data commands create, and these commands actually come from Eventide. And we want the create command identifier equal to the registration ID. And we want the data that we insert to be user ID, email address, is email rejected. This is the insert registered command, so it's not rejected. Is registered. This will be true. And created at will be time. And then with that, we'll use insert create command, and then we'll record telemetry. And then we're done. Okay. Yeah. Let's see this in action. Okay. I actually want to, let's do test init. Okay. Okay. So let's get controls registration ID, email address equals controls email address. And then we want our user ID equal controls user.id. Time will equal to controls time effective. Let's use raw.example. Actually, let's use this. Okay, yeah, our ISO 8601 format. Okay, now we have data command, insert registered. We want to build. Okay, so then we want to actuate the call command with registration ID, user ID, email address, time. Okay. And then what should have happened is Okay. As you can see, it inserted that data. So that definitely works. Let's go ahead and truncate. Okay. Okay, so we know that this works. Now we want to write a test for it. Um, let's see. Insert registered. So we'll require relative, automated init, context data command, context insert registered. So we've got our registration ID. And we want to, because this is going to be hitting the actual database, we don't want to use a control. We want to actually use a random ID. For user ID, we don't really care that much. And then email address, we can use control data. And for time, we need controls time effective example. Then we want our insert registered data command. Actually, no, we don't actually need this. We can do controls registration .id because we're not going to actually use .build. So, because we're going to use the predicate methods to test this rather than actually looking at the database to test this. Okay. Insert equals. So what is this insert? Remember, when we have a dependency here called I don't know what's happening. All right, here we go. Inside here, we have a dependency called insert, and that's what we're grabbing. And we'll run tests on this object. Insert matches name. Pretty descriptive. And this predicate method accepts a block. And then we can say name equals registrations. And then we can do that. Insert registered. Undefined method. Insert registered. Line 10. Data. Oh. Okay. And that seems to have been okay. Just to make sure that it's actually doing what we think it's doing, we could change this to something like that. Run the test and it fails. The names don't match. All right. So let's do the next test. Insert matches identifier. And it's very similar here. We don't need. we see it passed. And we can do the same thing for the data. Insert matches data. Okay. No, registration data ID is not part of the registration data. User ID is. Email address. And then is email rejected? Is registered? And created at. Yes, okay. And then we can do this again with some modifications. And everything looks great. All we need to do is something very similar for the insert email rejected command. Insert email rejected. I don't think. Okay. Yeah, it's all pretty much the same. Insert matches name, sure. Insert matches identifier, sure. Here's where it'll be different. True and false on these little booleans. They don't have the constant. Of course they don't. Here we can just select all, copy, paste. And insert email rejected. The substitute looks fine. The register telemetry sync looks fine. The telemetry, here we need to say we're going to record insert email rejected events. Same thing here. And here we want to say email rejected is true and is registered equals false. Otherwise, it looks, insert email rejected. And that looks fine. And it looks like the test passed. We didn't do telemetry tests. So let's do telemetry tests. We need to make sure that our telemetry test actually passes. So we can just copy this test and paste this, because a lot of the things we use there, we're going to be using here. We just want to add telemetry. Okay. We want a registration ID. We want user ID. We want email address. We want time. And we want this. We want to pass this in. But our tests are different. So we want to test records inserted registered signal. Yeah, I don't want. All right, that makes more sense. Inserted, registered, and same here. And I guess this would be rejected. Okay, so let's look at this test again. Records this signal, sure. Recorded. So we just want to make sure that that signal is equal to this. And then we will assert that it was recorded. Cannot load such file. Insert registered. Of course. Problem is that we need to do that. Undefined local variable sync. Right. So we have to register the telemetry sync. Let's go ahead and look at this, how it does it. So we just do this. Sync equals data command. Insert register telemetry sync. Undefined method. Do I have this wrong? Register telemetry. Oh, you know what? This is all in the wrong order. Wait, is it? No. This is in the right class. Insert module. Ah, here we go. Yeah, this is the wrong. Undefined method. Okay, we've got our module. Class self-sync data. Ah. Okay, assertion failed. Inserted. So we're definitely making progress. Okay. Insert registered. Inserted registered. Let's see. Okay. Oh, you know what I think happened? Telemetry is not being configured. So what I'm going to have to do is I'm going to have to actually operationalize this. And because of that, I'm going to have to use a random identifier. Yeah, that worked. Okay. Back to here. Why is this test not working? Oh, it worked. Okay. And then I suppose we can just copy this test. Insert email rejected. and just do the same thing. Insert email rejected, just replace this all. Insert email rejected. Inserted email rejected, signal. And those tests pass too. Excellent. Yeah, so we have our insert email rejected and our insert registered data commands. And these will be used by the handler to actually insert tuples. I think if we actually go ahead and look at the database, because of those tests, we actually have data in there that we may have to, we have data in there that we probably need to truncate. And there we go. All right, let's go ahead and create the handlers for this. Now, before we do that, we need to, we need to load the client, registration client. And then we need to, I think, we need a store. Which again isn't very, it's not very complicated here. So we just copy this and paste this. Registration. And then this category, we will use a registration view data, not registration. The entity is this registration, the projection is projection, and the reader is message store Postgres read. And then we need, let's see, we need handlers. So let's go and just copy them from here. This is probably, let's copy this one. Copy. And paste. But we want to rename this to handle registration events. And this one, we want to email rejected. And this one we'll rename to registered. And we'll go ahead and do this one first. Handle registration events. Registration email rejected and email rejected. So we have we'll have a handler called handlers registration events. We'll have a process time. We'll set that process time, and we need the registration client controls events email rejected. And here we want to set registration email rejected to differentiate from registration email rejected and this view data's components. Let's see. We don't need this, but we do want registration ID equals registration email rejected dot registration ID or fail. We let the handler handle that. We write it, and we want to make sure that the writer writes an email rejected event written to the registration view data stream. Registration view data registration ID. And then everything here looks fine to me. And of course, those failed, but we don't want to just stop there. We want to actually go ahead and get expected version as well. Registration, email rejected, expected version. Registration, and let's go ahead and copy that. Let's see. Registration email rejected. Oh, we don't really need this stuff. We want registration. This should be correct. And then for our ignored test, handle registration events. Registration email rejected, ignored, registration. Whoops. Let's just capture that. Okay, I don't need that. And then we want to pass this into the store so that we know that it's rejected email is entity version, and this one is email rejected event is not written. Okay, now that we have our tests here, we can go ahead and write our handlers. And let's load them up. Something like that, I guess. Let's go ahead and copy this. Not that one. Select all, copy, paste. Okay, here we go. So of course this is registration view data, and it's the registration events that we're looking at. Log dependency handle, yep, correct. So we do want to write and clock and store dependencies, but we want a lot more too. So this category needs to be view data. And I'll just delete all this stuff because we don't need it. Instead, we'll handle the registration client, messages, events, email rejected. All right. So we need to set our dependencies here. The first one we need is the session. Okay. This is the session right here, the view data message store session. So we need to write, so we'll pass this in into the right configure method. And we'll also pass that into the store because the store needs to be able to read messages from the view data message store in order for these item potency checks to work. In addition, we need a let's put it right here. We need a view data session. And actually, let's put the data command stuff all in one place. Data command. And the default attribute name is session, but we want to set the attribute name to view data session. And then we need a dependency for our insert. Right now it will be insert email rejected, data command, insert email rejected. Similar thing here. We configure it, self, and set the session to the view data session. Okay, so once we're here, we can do registration ID equals email rejected registration ID. And it's very similar. We're getting the registration entity from the store and the version. We're fetching it. And then if the registration email rejected, we return. Let's write a log message. Okay. Okay, once that's done, let's get the user ID, email address, the email rejected time, and pass that into the insert object. Okay, once that's done, we can then go ahead and write a message to the message store, the view data message store to be precise. Right, okay. Email rejected equals email rejected dot follow. And we want to set the time equals to, the process time equals time. And then we want to write the message. With this version. Let's go ahead and test. Uninitialized constant. Let's go. I think what's going on is that these tests are interfering, so I'll delete those. Okay, so we've got undefined email address for registration. Oh, it's maybe it's in here. Email address. Ahaha. Okay, still getting an error. Undefined local variable registrate. Oh. Right. Okay, now we're getting an expected version error. And I suspect that's because we don't have a version class here. So let me go to the controls and just copy this stuff here. Copy. Paste. Oh, it didn't copy. Let's do Control C. Control V. Okay. And then we go to this loader file here. Okay. Assertion failed. Let's see. I might have written the test wrong. So we've got our event from the registration component. Let me look up here. Registration, new. Oh, I see. I think this one needs to be like that because there's no ID here on the new example, so it needs to have an ID. Anyway, this seems to work. All right, and we can just copy and paste this here. Registered. All right. Registration, registered. This we need the registered event. Registration, registered. And we have this. We need this. This is correct. This is correct. We need to make sure it's an instance of registered, not email rejected. And this is also going to be pretty straightforward. Registration, registered. Registration registered. And registered. Delete this. No. And then let's look at this test. Right. Yeah, this should be fine now. And of course, this didn't work because we don't have the handler written for it yet. So we need to add a dependency for insert registered. Right, okay. And we can pretty much copy this. Okay. So here, we want to handle the registered command. And here we want to label this registration registered. Here, the event name is called registered. And we insert into registered. Okay, that seems to work. One thing we forgot was to test to make sure that the telemetry was activated. So, let's go ahead and do that. Just boilerplate. Let's just copy some of this stuff over here. We want the handler, we want the event, and I think, yeah, that's it. Before that, though, we want the insert class, and then we'll handle the event, and then we'll test the telemetry sync. Insert email rejected signal. And that passes. And then we can copy this and do the same thing for the registered event. Insert registered. And then records. Inserted registered signal. Insert registered. And that works too. All right, this is pretty much done. I think all we need to do is set the consumer and the start object. So let's go ahead and do that. And I'm I'm just going to go copy that from here. Consumers, delete these ones. Gonna need to rename this. Place that. And we had to change the identifier because we're running this consumer on this registration category from the registration view data component. So we don't want to override the bookmarks for the other consumer and have them collide or interfere with one another. So that's why we do that. And then we need the start command. Okay. And with this will also be, let me just copy and paste this so you can see the differences. Here we go. So we only have the one consumer, which is registration. We don't need any correlation, but something's not. All right. Was that the problem? Let me see. Okay, good. All right, so we need to, like we said before, we need to get the settings. We need to get the settings from for the entity message store. So we need to do that in a specific way. So we can grab settings like this. Now we have a settings object. Now we need to get the data hash. Entity message store. Okay. And then once we have the data, we can set a separate settings object. Message store, Postgres. And if you like, I'm just doing what I did over here and doing it again. Message store, Postgres, settings.build, entity message store data. And then I can pass the settings file, the settings object, into the consumer, and then it'll generate its own session. Let's see. Uninitialized constant consumers registration. Consumers registration events. So that looks fine. But the consumer may be wrong. Undefined local variable or method. So probably here is incorrect. Entity message store settings, entity equals entity message store data, message store data equals settings.data.dig, registration view data. In line, is that in the start script? Right here? Yeah. Invalid input. Right. So I need to go truncate a lot of data. Okay, there's no messages in there. Whoopsie. Okay. Okay, truncate that. And I probably need to truncate this as well. Let's put it in a different window so I don't get confused. Truncate this. Okay. Okay, so it looks like it is definitely working. It's got a consumer for registration view data. It's reading from the category registration with the identifier registration view data. And it's going to process email rejected and registered events. So let's do this for the first time. Let me go ahead and open PSQL. Cool. Right now we have nothing. The view data component is running. The user email address component is running. Let's write a registration message. The registration message was written. And then let's run the registration component. Okay, so this one wrote a registered event to the registration stream. The user email address component worked, and okay. So we clearly see something. Oh, I know why. We set this to UUID. Oh, wow, let me go open that up. Here, this is UUID, but clearly it doesn't because we defined the table schema to use UUID. These aren't UUIDs, so it's going to break. All right. Before we continue on, I'm going to write a script to go ahead and clear out the database each time because it is annoying to have to do it every single time. So let's go here and write a script to clear tables. This is a bash script. Clearing message store tables. So we'll run PSQL. And truncate message store dot messages restart identity on message store. And do that again for the view data message store. And this is going to be registration, registrations, view data, echo, echo. And let's go ahead and delineate this. No right. Oh boy. Guess I need to do that again. Okay. Let's make that executable and run. Unexpected token. Ah. Okay. Let's start this up again. Let's start this up again. We need to actually go ahead and change these. Get, I think, yeah. Actually, I'll just move this, and that should get me what I want. So this one worked correctly, this one worked correctly, and this one looks like it worked correctly. Let's go ahead and see. And yes, we can see that it was properly registered. Okay, now let's test to make sure that if we try to do another one, that the second one will be rejected. And it looks like it was rejected. That one worked, that one worked. And yep, this one is true on is email rejected. So now we have a fully operationalized view data component. And I believe that no matter how many times you try to reprocess these messages, these will be ignored on the second time. See, event ignored. Actually, let's go ahead and look at the message store on the view data server. Let's see. Oh, do you want that? Let's see. as you can see, the first message is a registered event. That's the one we inserted first. And it's saying that when we have this in the view data, registration view data stream, we know that the tuple was inserted into the registrations table. Same for here. If we have an email rejected event, we know that the tuple was inserted into the registration table. Let's just take a look at that again. False and true, true and false. And the global position, this sequence was auto-populated. And we have the dates as well. All right, so now we have pretty much everything we need. And now, so we've completed our registration view data component. We have a registration component, we have a user email address component, we have all of our database entity schema sorted out. If I look here, do we have the correct roles? Yes, we have registration resource. So all we need to do now is update our registration resource project with the registration client and the ability to query the new database. And that's what we'll do. So just a quick recap. We've created a user registration component, a user email address component, a registration view data component. We have database schemas for message store, our registration service, which has specific roles for that message store, and registration view data, which have our table for registrations. Now, let's go ahead and, so we have all these components ready. They're working, but we need to hook them up to the registration resource. So we need to go to this here, and we need to add the dependency for the registration client. So let's go ahead and do that. But because it's not on Ruby gems, I'm going to actually put it in the gem. I'm going to define it in the gem file. All right. So I'll go here and reinstall my gems. Okay, and it looks like the registration client was installed. So I can go here and add it to the loader file. And then it should be good to go. Something we might also need, remember, the only user inputs we're getting are registration ID and email address, but we still need, let's go back here to our command. We still need claim ID and user ID. And for right now, I'm okay with randomizing those, but we will need a separate dependency. We're going to need EVT identifier. We've seen this before, but basically what this does is just generate a UUID for us. So and we'll have to reinstall our gems. Okay. So let me go here. So here's where we're going to do our database IO. But let's go ahead and we need to, in order to use the identifier, we're going to have to set a dependency. And we need to configure our dependencies. Okay. And then we can go here and say, hey, user ID equals identifier.get, claim ID equals identifier.get. What was that message look like? Registration ID, claim ID, user ID, email address. Okay. We're also going to need some sort of clock, I believe, because we have to set it ourselves. So I believe we can just say we go here, add runtime dependency EBT clock. Yeah. And I'll just let that run in the background. And then here we can say clock UTC. Cool. And so we'll get time equals clock.iso 8601. And now we need to actually generate the message that we want to insert into the message store. So we go register equals register.new, register.registration ID, and just go on down the line. Let's see. What was it? What was the order? Claim ID, user ID, and email address and time. And then we want the stream name to be registration ID. No. Actually, wrong. We want it to be this command. We could use a helper, but I think hard coding it is fine as it is right now. Now we also need a way to write this to the stream, and for that we need to set our settings. We need to set our connection settings. We don't have any defined yet, obviously. So we are going to need we're going to need some more dependencies here. All right. We're going to need EVT messaging Postgres. I think so, yeah. So let's install that. And then let's go ahead and add that. Messaging Postgres. Okay. And then I guess if we're already doing that, then we can just include messaging stream name. And we can also include registration, client, messages, events. That way we can call this without using all of the namespaces. So then if we included the stream name module, then we'll have access to the command stream name, I think. But if we want to do that, actually we'd have to set category. And I don't know if I want to do that. Let's see. Actually, I don't think we need to do that. Command stream name. We can just probably, I think we could do this. Registration ID, and then registration. And so that should generate for us. And then, oh yeah, we need to write it. We need to write it to the message store. So, where is it? Command. Here we go. We need to set another dependency. And then we need to configure it. And then we can write the message. Okay, now, like I said before, we don't have any settings, as we need to define those. So we're probably going to need to add EVT settings. And then just add it here. Okay. I think I can just copy the registration view data settings for our purposes. Paste and set our get ignore. All right, that's already been set. Registration resource. Registration resource. And let's just update a couple of things here. We'll change that to registration resource. Let's change this message store because there's not two message stores that we need to differentiate against. And then we have view data. Let's copy that. Paste. And our user is registration resource. And our user here is registration resource. But the host name and port are correct. Let's see. And then we're going to need to set a settings file. And we're also going to need to set a session file, although this should probably go below that. Let's see. Okay, this all looks good. So let's add our settings file. So module resource. Whoops, wrong. Registration, module resource. Class settings. This is all very familiar. We've done this before. Settings. And then we want to set our singleton. And then we want, whoopsie. Then we want to set our data source. This is defined in the parent class settings. So I like to set a default. And just in case I ever need to set an environment variable, I shouldn't need to, but you know, it's nice to have. Otherwise, we'll use settings registration resource.json. And then, okay. And then here we want to add our session. And now here's our session. It's going to inherit, it's going to be a subclass of message store Postgres session. And then we need, this is boilerplate. We need to set our settings. And then we need to set our build factory method. So how do we do that? We just get the settings instance. Then we get the hash from within that settings. Registration resource settings .data.dig. Registration resource. And message store. And then once we have that, we set message store Postgres settings. Message store data. And then the parent super method will construct a session from that. And then here we set another dependency equal to our session class that we just defined. And then we need to configure that. And then we want to pass this session into our write class. And then I think we got it. Only one way to find out though. All right. Did I? Okay. Let me go ahead and change this script to dev server. Cannot load such file. Registration resource session. I might have. Resource. Ah. What's going on here? Undefined local variable or methods. Okay. So many typos. Okay. This looks like it's working. Only one way to find out. Let me see that. Let me check to see that I've uh, truncated um, my messages. Yeah, okay. And then I'll go ahead and curl this. I'll curl this resource with data registration ID, I believe. I know that non-UUIDs are going to fail, but none of the processes are on. I'm just checking to make sure that the command message is actually written. Okay, uninitialized constant registration resource command register. Oh, I know what I did wrong. I used events here when I should have used commands. So let's stop that process and try again. Okay, it looks like that worked. We're getting a HTTP response code of 202 accepted. We're getting a location header of HTTP ://localhost:9292/abc, which is the registration ID I sent in. And then, whoops, it did look like something was inserted. Yes. So we've got our time. We've got a register message sent to the registration command stream for ABC, registration ID ABC. We've got our time. We've got our user ID. We've got a randomized user ID. We've got a randomized claim ID. We've got an email address of jane@example.com, and we've got our registration ID with ABC. Now, I'm going to truncate this because it will fail. Truncate message store, messages, restart identity. Okay. Excellent. So that looks like that works. Let's go ahead and I'll go ahead. I want to actually test this with a real registration ID. So I'll go grab one. I don't know why it's doing this weird color thing. didn't used to do this before. But anyway, okay. Controls registration.id. And I will just copy that. Yeah, okay. Application JSON. D. I will paste. Did I mess up? Ooh, yes, I did mess up. Let me go ahead and just copy this. I don't want to retype everything. Copy. Paste. And then I'll copy again. Paste. Failed to parse body as JSON. Okay. Registration ID, email address. Oh. There we go. Copy. Paste. Failed to parse body as JSON. So there's still a problem here. Curly braces, registration ID, colon, email address, colon, jane@example.com. All right, I'm just going to, because I know that this worked. So I'll copy this. Paste. And then I'll go ahead and copy this. Paste. Oh, that's probably why, because there were line breaks. Okay, this should work. Fingers crossed, though. Okay, yes. So we've got our location, 202 accepted. And yes, we've got a registration ID. Now, to simulate our web client polling constantly for this this resource right here. This is what we should expect to see. Well, no. Okay, so we still haven't addressed that. Because if you looked, we have an HTTP 200 response, and we have a payload here, but nothing has been run yet. So what we're expecting is a 404 error, but that's okay. Okay, so and it's basically just sending back a hard-coded payload, and we wanted to actually query the database. So and that database information is here in the Vue data. So let's go ahead and add a dependency. Let's see. We're going to just add my view data Postgres library, which has a an API to query tuples from the database. So we're going to want to install gems. Let's let that run. And we're going to what router dependency. I guess I could put it right here. So that's our loader file. And I'm going to create a separate class to query this because I don't want this class to get too loaded up. And we're going to also need a session. Okay, so let's go ahead and do that. Actually, I think it would make sense to go ahead and do the same thing with this. Like, I think this is a little, having all this in here is very bulky. So yeah, let's go ahead and take a slight detour. Okay. Let's go ahead and just select all, copy, paste, and let's just make this. Whoopsie. Okay, so there's not much we need to do here. We have all of our dependencies, registration, session, clock. Yeah, that looks good. This looks good. This looks good. This is fine. Our inputs are going to be different. And we're going to want email address. We're going to want claim ID. User ID. And I think that's it. We're going to set time. This is fine. Yeah, that's fine. Actually, do I need whatever? Let's see. And then we just write it. Okay. And then in our command, we don't actually need all these dependencies. We don't need that. We don't need this. This. We don't need this. Or that. Okay, So this is where we were before, and actually I lied. I misspoke. We don't need to pass in claim ID or registration ID, or claim ID or user ID, because we're generating those. Equals identifier dot get, user ID equals identifier dot get, right? Okay. Here we just pass in registration ID, email address, and then oh wait, yeah, I do need dependency. I deleted that which I needed. Register. It's okay. Def configure regis.configure. Does this work? Yes. Register builds. Yeah. And then now this is a little bit cleaner. Let's go ahead and I'll just leave that there. Run this and run our curl command. The undefined registration ID. Let's see what line that is failing. Line 39. Okay. Registration ID, email address. We're passing registration ID. Am I looking at this? Undefined method registration for. Oh, oopsie. I see what happened. This is messing with this. There's a namespace collision. Let's call this. Let's just not worry about this. Yeah. So let's just say registration client messages commands register, and then that should be fine. Yes, we've got a location, and we have a second message that was inserted. Excellent. Okay, so we want to define our session here for the query. Let me look at the resource JSON file again. So we want registration, view data. Got it. And we want to define our session to be a subclass of view data Postgres. And we want to define our factory, our constructor. I think I'll just, it's pretty much the same. here. Let's see, registration resource settings. We're getting the singleton. We have our view data. um, and then we want our view data settings. This is view data Postgres settings dot build. View data and view data settings. And that should be okay. Now we want to define our query. Okay, we're going to need to include the dependency module, and our dependencies are session, and this session is referring to this session. And we also need get one from view data Postgres get one. And then we do some boilerplate. I'm just going to copy it from up here. Paste. And we'll just say this is get registration. Let's see. Build. Configure. We need to configure a session. That's correct. But everything here, we need view data, get Postgres, get one dot configure self, and pass in a session. Okay, def call. We want to we're querying a specific registration ID. Now let me write my SQL statement first. Well, what's the operator? There, yeah. I believe this is the correct syntax. And then we do select. I really just care about the booleans that we defined in our table schema. I don't care about registration ID, user ID, email address, or anything like that. All I really want to know is was the registration email rejected? Was the email rejected, or was registration successful? And then registrations. Where registration ID equals $1, and we want to cast it as a UUID. Yeah. And then we say, let's define a query from, this is from my library that I wrote, Postgres query.new, query.name, registrations, that's the table that we're querying. It's really not really necessary, but because we're just using a statement, but it's used for logging purposes. And then our parameters, registration ID, and we want to return a tuple message class, and we define the tuple right here. Attribute is email rejected, and then we want Boolean. Attribute is registered, and we want Boolean. And this is going to map data from our query to this class. and it will return an instance of this class to our query here, to whatever is calling it. So let's go ahead and include dependency, define a dependency of get registration. There we go. And we've got registration ID. And now we get our registration. Yeah, I think I like that better. Maybe I'll just, yeah, we'll. And then so we need to make sure that the registration, if registration.nil, we want to return error. And unless registration so this is just another check to make sure that there's data that I'm expecting. One of these has to be true or false. We coded our view data component in order for that to be true. But just in case, if both of these are false, then we want to return an error. But otherwise, we want to return let's see, registration dot is email rejected. Is registered. And then everything looks good here. So what's the error? Let's go ahead and define that, because that will be our first test. Body equals something like error. Registration is not available. Header content type application JSON, and then we'll return a rack response, body 404, header, I think we use .finish. So return error response, return error response. Let's go ahead and test this. Let's go ahead. We just need to grab this location. Copy, paste. Undo. Ooh. Okay. Our get query registration. There we go. Let's try again. I'm just not having a good day with regard to typos. Right. Let's restart this. And okay. 404 not found. That is what we are expecting, because if we go here, and we select from registration.registrations, we see there's nothing there. So we need to actually turn on our components. And as soon as I do this, it will all start processing messages. And now we can see that we get an HTTP 200 response with the payload of email rejected false, email registered true. Okay. Now let's go ahead and see what happens when we change this registration ID and try to query that. So let's go ahead and paste this. It accepted it. It accepted the payload. And let's go ahead and curl this resource. I'm expecting the email to be rejected. And yes, the email is rejected. We receive a 200 response, and email is rejected. Registration is false. So that's pretty much complete. So what did we do here? Let me just recap. We were able to demonstrate that. Let me close these. Yeah, I can delete this. We were able to demonstrate this whole thing. We post a payload to this resource. We get back a response of HTTP 202. And we and we get back a header location of something like this with the registration ID here. And then we query the registration, this resource. Our first couple are going to be 404 responses as the registration component, user email address component, and the registration view data component run. And then eventually they will get back an HTTP 200 response with a payload of whether the email was rejected or whether the registration went through. Okay, now we just need to go to our web UI. I'm not sure if there needs to be any updates to this because it's been a while, but I'm fairly certain that we have our retry logic here. You know what? Let's go ahead and do it. But before we do that, let's run our clear tables script. Let's restart this. So everything is starting from a blank slate. We need to start this. The registration. We need to start the registration resource web server, and then we can start our web UI. And then here we go. We've got our user registration. I think we did everything through console logs. So let's go ahead and say jane@example.com and register. As you can see, our first four queries to the, I don't know if you can see it, it's kind of small. But our first four queries to the resource returned 404 responses until finally we got a registration successful console log. Let's go to our network tab, and you can see, hey, we're querying, and we're doing an exponential backoff, and then finally we get a payload that says, yes, we are registered. Let me refresh this and do that one more time to simulate. Oops. To simulate if the email is already in use. Similar thing here, but the email, we discover that the email address is already in use. And I believe that's it. So what did we do? We did a lot. I don't know how long this whole tutorial is, but yeah, we created a web client using Vue.js, and this client communicates with our registration resource, which accepts messages and writes a message to the message store. And then the registration component completely asynchronously takes that registered message and first communicates with the user email address component to make sure that that email address is unique. And then once that's done, if it's not unique, then it returns that it writes a message to say that email address is not unique. Otherwise, it says, okay, this registration can go through. I'll write a registered event. And then our registration view data component takes those events and updates our SQL database, which our registration resource can then query. And then our web UI is just constantly polling in an exponential backoff. Eventually, it will stop. But once all these asynchronous components become eventually consistent, our web UI will finally get a valid response. Actually, let me go ahead and show you what will happen if, like, say, there is a problem with the components. So let's go here and here. We've closed all of our components. The only things that are running are the registration resource and our web UI. So if we go here, let's refresh. And register, it just continues to poll. And it's pulling at an exponential backoff until finally it just stops. So this is something you can expect to happen in event-sourced in an event-sourced system. Yeah, I think that's it, guys. What do I want to say? One more thing. There's one final test that I wanted to demonstrate. Idempotency, i.e. the dreaded double click. So here's our web UI. And before we start the test, I want to show that we're starting from a completely blank slate. So here's our web UI running. And here's the registration resource. And here's the registration component. And it hasn't processed any messages yet. And here's the user email address component. Hasn't processed any messages yet. And the same with registration view data. And just to make sure, let's go check the database. So here's the message store. And let's check the message store messages. Okay, there's 0 messages in the message store. And let's also check the registration view data database. So there's 0 rows in the registrations table. Okay. So let's input the email address. And I'm going to double click now. And what we should expect to see, the web UI will send 2 registrations to the registration resource. And so 2 commands will be written to the message store. But only 1 registration will actually be registered. The second command will be ignored because of our idempotency protections. Okay, I'm going to double click now. As you can see from these console logs, there were 2 registrations sent to the registration resource, but they were all using the same UUID. You can see that here in the location or the path to the registration resource that they're querying. We can also check the network tab. We can see these queries being sent, all this polling being done, and then finally a success message, HTTP 200. Let's also check the database. So if we check the message store, we see that in global position 1, there was a register command. And then the registration component wrote an initiated event. And then in global position 3, we see our second register command written. But this one was ignored. And we see only 1 registered event. Likewise, if we go to the registrations table, we see that there's only 1 registration tuple inside the table. And that's it. I already recapped once before, so I'm not going to do that again. But I think you can begin to see the robustness of this kind of system. A service can fail, and only certain parts of your web application will be showing errors, as opposed to a monolithic application, where a single point of failure can bring down the entire system. Not to mention that this kind of system is resilient due to the idempotency and concurrency protections that are in place. Of course, this very simple application took a lot of moving parts and a lot more time to build than a typical monolithic application. And like I said before, I'm not trying to convince you to use event sourcing or service-oriented architecture in every application that you build, but it's useful to know different architectural styles and apply them in familiar contexts. Maybe you might start using concurrency protection or take idempotency into account in your own application. Don't just prevent those double clicks. Okay, that brings this tutorial to a close. If you made it this far, wow, congratulations. It certainly was a long one. If you have any questions for me, be sure to check out my website, josephchoe.com. As I said before, I will be hosting the repositories on GitHub. Or you can message me on one of the many social media platforms I'm on. Give them your sweet, sweet engagement metrics. All right, thank you. Until next time.